You made it! Welcome to Vienna. We are so glad you're here. This event is part of Vienna Up, the Startup Festival. Have you got your Vienna Up wristband? Put it on and enjoy special offers and activities. Swing by the festival home base, say hi, hang out, and enjoy Viennese Hour to sample local food, wine, beer, and soft drinks for free. And have some fun while making new connections. Visit partnering traditional Viennese coffee houses to sip a free melange, meet new contacts, check your email, or just have ideas both crazy and grand. Enjoy Vienna. Go to viennaup.com, sign up for the newsletter for daily highlights, and we'll see you at the home base.
Hello everyone and welcome to another live day from WeAreDevelopers. My name is Bene, I'm community manager here at WeAreDevelopers, and I'm glad that you all made it today. So today is all about machine learning, but before we start with the first speaker of the day, actually some information beforehand. First, the Vienna Up, which we are proudly a partner of, started yesterday. So if you're based in or around Vienna, make sure to check out the link in the chat. And also, regular viewers already know it, but as an information for the new ones and a reminder for the regulars, our World Congress is back as an in-person event starting end of July in Berlin. Check out worldcongress.dev for further information and make sure to claim your tickets. And during the talks, feel free to interact in the chat to your right. If you got any questions, submit them via the big blue ask button. The speakers will gladly answer them. But as usual, be nice to each other and respect each other as we have a code of conduct. Here's a short video about it. And now let's start right away with the first speaker of the day. He is CTO and co-founder at Codete, has a PhD in computer science, built a research lab for machine learning and big data solutions, and likes to share his knowledge by giving trainings and talks, such as ours today. Welcome, Karol. Hello.
Hi. Hi, thank you
so
for the
much for
introduction.
joining. Karol, before we start with the talk, would you like to share with us what we're going to learn from you today?
Sure. I will explain what explainability is in machine learning. So how to do this, why is it actually so important? What kind of industries are affected or needs to actually use this kind of a to the security, and hopefully many other topics that I will cover during the 45-minute talk.
All right, Karol, then I don't want to steal any more of your precious talking time. Sounds all very interesting, and I would say without further ado, the stage is all yours.
Thank you. So explainability or explainable artificial intelligence, that's a topic that is known for I mean, it is not super new, but it's in the recent years, it became more and more popular for various of reasons. When I started my journey in machine learning, it was in 2007. So it was around 16 years ago from now. Machine learning, when I approached the potential customers, they didn't really there was no pressure, there was no they didn't have this kind of feeling that machine learning will solve some of the challenges they have at that time. Actually, 2007 is just 1 year after Jeffrey Hinton published his paper on deep belief nets. What started actually the kind of a new life or new hype on machine learning, because this is actually when the deep neural networks became more and more popular, and we also see the applications now. So now it's a bit different compared to the 15, 16 years ago. Everyone wants to do machine learning, or many companies want to actually implement machine learning solutions. But well, on one hand, we have the model, right? So we build a model that solves a problem, but it also comes with a challenge, like, okay, does this model works well, right? Because even if we have kind of a quality metrics like, accuracy, sensitivity, specificity, and so on and so on, still we want to know how the model really works, and some industries even need to use that. So since then, actually, just recently, we actually see many of areas, many of fields where machine learning has is used. And yes, it doesn't need to have. I would actually, I could just stop here, not telling anything more, because everyone knows that there are so many areas where actually it is used, right? But all of the industries where actually I would like to focus on today, specifically today, is there are two fields: is the medical field and the finance field. So the industries. Why? Because well, when we do, for example, when we have an e-commerce and to build let's say recommendation system, and we get high accuracy and other metrics that are quite high, we are fine with that usually. But when it comes to the medical field or fintech, it doesn't end here, definitely, because for example, if these two actually are regulated, right? So if we want, for example, publish or sell a product, if it's a hardware, software, or just software, that will give you, for example, medical diagnosis, right? So let's say you have an image and you send this image to a model, whatever is an app, or is it a web app, mobile app, it's a part of a hardware. It's still, it gives you a diagnosis, right? Decision. And at the end, well, to sell this kind of a product, you need to explain how the model came to this prediction, right? So how actually it came to that, which is not so easy to do. I mean, there are some methods that I will talk about today to show you that in some cases it might be there are some, let's say, good patterns how to solve that, but in many cases it's not easy to really explain the prediction, and there is another effort needed to really do that. You can compare it, let's say, in a typical software development to some kind of a QAs when it comes to explainability. You understand what's going on in that, because many of the models actually are black box models, so you don't know exactly what's happening in it, especially from a customer point of view, right? If you have an app, you don't know exactly what kind of, let's say, neural network architecture you have there, but you have an app. So if you use that, you want to know how it works. And the same from the medical doctor, right? If I use a model and an app, I want to know how it actually came to this decision, because maybe on one hand, I want to learn, maybe I can learn something from the AI. In these days when we have the GPT and so many people are talking about that it gives good results, here it's also a room actually to show medical doctors, how actually we came to the result. And similar in the fintech, in financial area, right? So that's also regulated, and we just can't actually publish. We can't sell a product that is not doesn't go through all of the certification, all of the regulation process to sell it, right? So we need to explain how it works. And there are several ways how to do that. when it comes to the name, because explainability or explainable AI, that's the most common term known in different kind of papers, right? But we also have two other terms that they're not exactly the same, but they, in many cases, they are used like an exchange. I mean, they mean more or less almost the same, like explainability. Explainable AI is the interpretable artificial intelligence and responsible artificial intelligence. Again, it's not exactly the same. There are some details, but in some cases they are used to mean actually the same. As I mentioned before, just to give you just a medical doctor, the medical doctor wants to know what actually how it works in the back, right? So a medical doctor is the domain expert, right? Let's say we have a neurosurgeonist, right? If such a neurosurgeonist look on the MRI scan of your brain, for example, he'll see if the tumor is there, if it's not. He already learned that during many years of training to find this kind of tumors, right? There are some patterns specific for one tumor, one type of tumor, and patterns for another type of tumor. And this is what the doctor learns for many years. So he's an expert. At the end, he's doing the surgery, so he needs to know exactly where to cut, what should be the procedure here. And if they use a machine learning model, they want to know how it works in the back, not specifically from a math point of view, because that's actually the easy part, right? To actually send the doctor some math equations and tell, okay, this is how it works. But that this doesn't solve the thing, the challenge for this doctor. They want to know exactly why this or that decision were made. The second, something that I already also mentioned, the regulatory agencies. If you want to sell a medical product, you just need to get the FDA approval. FDA, obviously, in the US, and similar agencies in Europe and other regions. That's part of that is actually is about to explain the method, the model that we have developed. If we are a company where actually it is already used, some of the models are used, we also want to explain that to the board members, for example, or the managers, to explain how it works, if it really gets the right decision, if it's going in the good direction, so if it makes really the right decisions. That's important because at the end they take the decision of the whole business, so they want to know if they can rely on some specific solution. And obviously the data scientists that want to know, you can think about like a debugging, like going into the model and checking what's going on there, to find out if it's the right or wrong, if it's working in the proper way. And at the end, obviously the users, right? If I have a mobile app, for example, with a model, I would like to know how it works. Yes, I know in many of such cases I'm not able to know that, but for sure as a user I would like to know how it works. In some cases it is obviously possible. So how to explain? There are several ways, at least a few ways, how to explain a model. On one hand, we have the research papers, right? So we can explain it with some math equations, and that's not the most convenient way, because if you get a list of math equations with some scientific text, for non-technical persons, it might not be the most convenient. It is true. I mean, it is valid because it's not fake. I mean, it's the right thing to describe a model. But for many people, a visual explanation might be a better one, because if you chart, if you plot something, if you show an image, they understand it way easier than some equations, right? I will show you some examples later. And if the problem is too complex, right? Too complex, or actually you want to just focus on a small part, so we can locally, right, take some local case here and explain part of the model, or take an example, right? So This is going on input. This is what happens during the training, during the prediction, and this is the output, right? So you can take an example of what happens with the example during the whole process. Sure, it depends on the model. If you need to go out into details or not, that's obviously case by case. And also similar to that, explained by simplification, right? To simplify if it's a very complex model, to make just the right, to simplify that, to just use simpler examples, and simplify the things that actually are in the model, right, inside of the model. And the last one is the feature relevance explanation, right? So what kind of features really we have, what kind of features are important. Maybe some features are not important at all, but that's actually also part of some methods to reduce the dimensionality, so reduce the number of features that we are putting into the model. So here I have an example. These two, because I did my PhD on skin cancer diagnosis. Here I have two images, two moles. One is a cancer, this the one on the left, and then the one on the right is actually not a cancer. It doesn't look good as well, but it's not a cancer. For many reasons, you have some specific features, right? In this case, you can see here the kind of dots. You can see, I don't know if you see my mouse, but you can see here the dots, kind of a gray dots here, or the stripes, right? It's asymmetric, definitely the one I'm talking about, the one on the left now. And you have kind of islands, right, of the black color, together with the red one in the middle and surrounding. So these are the features. I don't want to go into details what kind of features they are, but because there are more than 30 different features for skin cancer. And on the right, it's okay, it's a bit asymmetric, but in general, just a few, just two colors. And I'm saying that for sure because both of the moles were the surgeries just cut it, and it was checked on the as a histopathology interview. So it both checked if it's a cancer or not. So again, if he will actually, the model point out, okay, these are the dots, and this is why it is a cancer, then that's obviously a good explanation. So here I have an example of husky dog. If you know how a husky dog looks like, then you know also how a wolf looks like. Then for people who actually don't know how a husky dog looks like, they might actually not recognize or see the difference between the two animals, right? They look similar, but obviously if you have a husky dog or actually had one, saw one in the past, you will see a difference. So here's an example. Some researchers in the past, that's just one image from one of our scientific articles about explainability. Here you have a husky dog that was classified as a wolf. Even the accuracy was high, around 90%, which is, well, good enough, at least for at the beginning. It's fine. They tried to figure out, okay, why, or what are the pixels, what are the parts of the image that has the biggest influence, right, on the final prediction. And the thing is that most of the husky dogs, when you take a picture, you can take a picture, I don't know, in the garden, on the couch, at home, I don't know, in the park, right? So definitely together somewhere where humans, right, lives. On the other hand, you have wolves that actually, if you take a picture of a wolf, you will take a picture, I don't know, in the wild, like in the forest, usually also with the snow in the background, right? And here, as you can see, the gray pixels here on the right image are the no important ones, and the one that actually are important is they stay. And you can see, okay, the background, so the snow was here the most important important feature. That's not how we humans, and obviously the machine learning model as well, should not recognize if it's a husky dog or a wolf, right? Because we should think about features like, I don't know, ears, eyes, nose, and this kind of features instead of the background, because the background can change, and the dog or the wolf not. I mean, not when it comes to the features like ears, eyes, and so on. So that's how you should not do that. This is one of the cases where something went wrong, and explainability showed that actually the model, even with a high accuracy, doesn't really work well at the end. Well, here have another example. The one here on the right. This is a Tesla car that just crashed into the truck because this truck was recognized as the background, as the landscape, more or less. So that's also not good. Here about the Thai tweetbot. It's from 2016, right? So it is 7 years old. One of the big companies that they have built a tweetbot Thai. They call her this tweetbot Thai tweetbot, and the profile was a teenager, right? In 24 hours, it became racist because of the way how actually it was retrained and many other issues that happened there. But sure, now it's good to explain how actually it came to that, right? Or actually should be done before, but then after that, they just in 24 hours they shut down this bot. Explainability would help here to some degree, because there are also some security issues here that you can see about the retraining, but that's another topic. Or here, a stop sign that you can put a sticker on, and it's totally recognized as something totally different. It's called adversarial attacks. I will talk about it later when I will move to the security part. Or Alexa, right? Suggesting to suicide for a better good. To his owner, right? It was her, I guess. Yeah. So that's something that should not happen. We should explain how they came to this kind of a reaction. Or here, Google, right? Another one that shouldn't work like that. So what kind of methods we have to explain the machine learning model? We have the black box and white box, similar to the test types, right? We have white box unit test and then the functional black box test. It works more or less the same. I mean, the concept, because in the black box we don't know exactly how it works. I mean, we know exactly from the, let's say, math point of view, but we can't really specifically say, okay, this is responsible for that. Here I have actually a decision tree, which this is actually a type of a method, but that is explainable. I mean, a tree by design is explainable because you can easily switch. There are different methods to build decision trees, but all of the methods actually ends with a tree where that can be replaced with some kind of a if-else statements, right? And sure, if the tree is deep, like a really huge, then the explanation of that might be a bit more difficult. But still, you have one tree, right? Or, for example, linear regression, right? That's also very easy to explain, because you have a line, you have the slope, you have the BMI here, right? That's clear. You have the height, weight, and sure, that's something that is easy to plot. It's easy to explain. No, really, the method by itself is explainable, right? Same like decision tree. What is actually important here to mention, just going back to the decision trees, or just going here, is that sure, if you have one tree, it's easy to explain. But in many cases, like if we use, for example, XGBoost, or actually some ensemble methods, where we random forest, for example, where actually we use many trees, it might not be so easy to actually move that to convert it to if-else statement way of explanation. And in this case, it might be also a bit more difficult to explain such matter. So let me just show you just one example of what's the difference between the shallow, between the white box and black box. Okay, you should actually see my my notebook. It is actually available on GitHub. Feel free to take a look there. So let me show you a very simple neural network that actually has it has 1, 2, 3, 3 layers, right? 3 layers, not too many, right? Just 3. And we train it here, and then I just printed here just the weights just from one layer of the 3, right? So just one layer, and you can see there are some numbers here. So they are the values of the weights. If I ask you now, okay, what is this value about? What does it say? It's not possible really to say, right? On one hand, because the neural networks are constructed in such a way that actually it's very hard to say, okay, this or this weight is responsible for this or that. And second, usually when we explain neural networks, we just take layer by layer or parts. More numbers, more weights actually to explain. But that's something that I will come back later to show you specifically. And a white box matter, right? Here's a decision tree. If you plot it, right, that's a very easy scikit-learn decision tree classifier, simple case. Here you have the tree that you can plot. Sure, it might look a bit complex because you don't know what x2, x3, x1 is. Well, yeah, on one hand, why should you care, right? At least it's here you go through. You have a type specifically. So the x1, x2 are different features of this flower that they are in the data set, and you can say, okay, if x3 is lower than 2.45, then it's true. Then you have this type of flower. If not, then we just go to the next decision, and so on. And all of these decisions actually can be just revert to, rewritten to a if-else statement. All right. So just going back to my slides. Hopefully, we can see my slides again. What are the other things that actually are explainability about, right? Because as you saw the tree, there is the x1, x2, x3, and so on. So the different features. But let's imagine that you have a tree and you have a data set of 10 features, but the decisions in the tree on each of these nodes is actually done on only 6 out of the 10, right? Of your set. So it means that just the 6 features does have an influence on the prediction that 4, if you just delete them, will not change anything, right? So there are also different ways how to measure the feature importance, right? Or how actually the features affect the data, right? And that's also important here too. This is also what explainability is about, right? So what do we actually get from let's say a data scientist point of view? So we can debug, right? So we can debug the model, get to know each other a bit more closer, and understand it a bit better. Also, because as you know, now we are not really model centric. We don't really use the model centric approach. So the models are quite easy to implement. There are plenty of available in different kind of libraries. But the data, we just moved to the data centric approach. In many companies, you do that same, where actually data or the improvement of the data is crucial, right? Because the model, fit, predict with scikit-learn, that's it. But if you have low quality data, then you cannot achieve really high accuracy results. So what also gives you the explanation about the model is if you need to improve any kind of a feature engineering process, so getting the data, right? How to collect, maybe you should actually collect in a different way. Maybe should add some other features, right? Also, actually, then convert it right to the decision-making part. Remove bias, sure, to some degree. It's not really possible to remove it totally, but at least try to remove that, and obviously remove or eliminate the overfitting, right? You know, the few pictures that I showed you before are some examples of the overfitting. Other thing, from the debugging point of view, you know, we can say, okay, do we have any data leakage, right? If there is anything that, you know, it's happening not the right way. I mean, from the data point of view, from the features point of view, right? For example, right? Also changes strategies here to actually get the data and actually, you know, fit the data to the model. Again, the feature engineering, right, process. Maybe some cases. I will show you a Titanic example just in a minute to show you how actually using the same features you can. I mean, you are not extending the data set with new features. Sometimes you need to do that, but sometimes the features that you have can be used to generate new features. And I'm not talking about, you know, adding new dimensionality in the meaning like SVM do, right? So combining twos and actually getting higher dimensionality directly, but actually use, especially if it's not a number value, let's say, right? If it's not an integer or float, if it's a string, for example, a text, then it's easier to get something out of it. So exactly, let's move to the Titanic example. As I said, here we go. I hope you can see now also another notebook. So the Titanic data, this is a classic data set for many, you know, for if you want to learn machine learning, that's one of the data sets that you probably will work with. And the typical data set here, you have several of features like the, you know, the label obviously, and also some features, but there are some features that actually are text features like the name, right? Sure, the gender here, that's something different. I mean, that's something that is, yes, it is text, but you can easily convert it to a number. But the ticket, for example, or the name, that's something that you can try to convert it to something more interesting. And if you do that, I mean, I will not go through all of the here processing I did here, but if you do that without just purely using the same this data set will actually give you a accuracy of 78.7%. Sure, you can get also the features importance, right? You can see that the fare is not so important, right? Parch as well, or these two here are not important as well. Features from the list. But if you go and actually, for example, analyze the name and split it into tokens, right, and then actually find the most popular ones, you will find, okay, Mr., Miss, right, and so on, maybe a master. I don't know exactly what master means here, but that's something that some people use, maybe master in science. Master degree. Anyway, if you take all 4 of these and actually create another feature out of it, and also from the tickets, then you will find out, okay, maybe we can add 2 more features and then actually use it here. There's more calculation here done. Then you actually increase just by doing something simple here, using the same method with the same parameters. You can just increase it by around 2%. It's not a lot, but still, there is not so much work done here to really increase it by just a few percent. Especially if you are going higher, like, you know, reaching accuracy like 90% or something, then it's even harder to actually get such an increase of accuracy. So that's important to mention, that actually the working on the data, explaining the data, right? That's crucial. So data collection, human decision, building trust, bias removal, that's something I already mentioned. So the white box models, exactly, you know what's in it. What actually in the black box models, it's a bit different, right? Because you have many ways, like here, that are hard to explain. So more models that are easy to explain. The logistic regression that I just showed you with the Titanic example. K-means, like kind of a clustering methods, are more or less easy to explain. Here you have the airplanes, right? Seat count and range. you can easily make a group of 2 here, 2 clusters. So more or less easy to explain. I mean, k-means is one of the example, obviously. Or decision trees, right, that I mentioned before. If you convert the if-else statements to hyperplanes, so decision boundaries, you will get something like that, for example, right? So that's also something, if you plot that, that's also easy to explain, especially if you change x1, x2 to specific feature names. Or SVM. SVM, these are quite complex from a math point of view method, because you have the Lagrangian multipliers, and you have also the infinite dimensionality that can, you can increase the dimensionality as you want. So it sounds like a complex from a math point of view method, but it is still SVM is still recognized, considered as an explainable method because of the way of how actually the decision is made at the end, right? So we have the boundary here that is easy to plot. Or reinforcement learning. This is a simplified, obviously, graph, right? When it's like training a dog, right? Training a dog to sit, to give, sit or lie, for example. You give a cookie, right? Then the dog will do that, and this is how you train the dog. Similar here with reinforcement learning, you just give a reward when it behaves in the proper way. All right, so I have more examples here that you actually can take a look on. Here we go. But here I have the linear regression with the Boston housing example, right? One of the things that I would like you to actually take a look, or maybe think about, is that sometimes just plotting in a 2-dimension, because we as a humans, we easily plot something in 2 dimensions, like here, right? But sometimes actually moving into a higher dimension, right? Because as you can see here, it's a bit too big here. Plotting something in 2 dimensions like here might not give results, as you can see. I mean, we have the slope, right? Great, cool, but it doesn't tell us much. Especially if you want to explain how it actually divides, right? How it actually makes the decision here. So maybe we can just add a new dimensionality like here, and just add the slope hyperplane here. It might be much easier. I mean, sure, 3 dimensions is still something that we can easily read. 4 dimensions quite hard. More dimensions, very hard to do, right? And so linear regression, for example, right? You can grab these notebooks, play with it, or logistic regression that I showed you before, or the SVM here again, multidimensional logistic regression, as you can see, right? More explainable than this one, definitely. Or yeah, SVM, for example, right? So that's something that you can easily also draw. And many other ones. Because of the time limitation, I will just move back to my presentation, and please feel free to actually grab the notebooks and take a look at that. So what kind of methods we have? We have more explainability method this time, not machine learning method, but explainability methods. We have one that actually are based on the feature influence. So we have 10 features. What kind of feature is the most important? What is the influence of each of the features? The output, so we get an output from the prediction, explain the output, or actually extract some features from the neural network layers. And there are plenty of methods. I mean, explainability methods: PDP, L, ICE, Shapley values, Sharp, Lime, and many other. Right. For example, PDP, the partial dependency plot, we see how what kind of feature has the influence on the sales here, right? So predicted number of bikes that we sell, and the temperature, what is the influence? Sure, I mean, in this case, it's obvious. If the temperature is higher, people buy more bikes, right? So that's clear. With the humidity, sure. If it's raining, then well, they are not buying so much. There is a source here. Feel free to actually grab this book. It's a free book, very good on explainability methods specifically. that I can recommend you. So what are the pros and cons? Clear, in this case, it's clear interpretation, easy to implement, but it's actually limited to a number because it's 2 dimensions, right? Highs, where actually we use much more of such PDP plots, right? Combined, and we try to find some trends. Also intuitive to understand. Again, same problem with the number of features that we can display. And also we might have some noise. Accumulated local effects, similar, right? It gives more information, right? Because we don't have specifically here the prediction of bikes that are sold. On the other hand, it might be a bit complex, really. So PDPs are just faster and easier to get. Or the Lime. Lime is another method. Actually, you can find the difference, right? Explanation, especially when it comes to the images. That's where actually it is very useful. At least in my case, where actually I use that. Sculpt rules or Shapley values, right? Another ones, specifically Shapley values, where actually you use the game theory. So it means, okay, what will change if we will change that? What will be the prediction? So that's another method how to do that. I actually wrote a book about that. I mean, not specifically about Shapley values, but about some of the methods for the medical field. For example, SHAP, right? SHAP, as you can see here, if you remember the slide about the husky wolf dogs, you can see, okay, the gray here you have the gray areas, more or less important parts of the pixels. Or let me show you. That's not yet published, so that's the first time I show that. I don't want to show you all of that. That's a book that I've wrote just recently. It is now the review. Here's an example of the SHAP method, right? Showing pixels. I mean, the red one, the red parts of the image. This is actually a skin mole, right? Just to be clear that the red parts show you what part of the image are has what kind of pixel has the higher influence to the final prediction. The blue ones, where the pixel doesn't have so much. Or have a negative impact on the prediction. And you have here the names of the prediction, like nevus, melanoma, vascular, the BCC, so the different kind of cancer. And you can see that some of them doesn't really have, because it's not the prediction here. As you can see, it was predicted this mole was predicted nevus, so fine. I mean, nothing really big. So I hope it will be published in a few months, a few weeks, so you can grab that. It will be published in the Springer publisher. So SHAP, something that I showed you, it is a combination actually of Lime and Shapley values. All right, so the last part, no, not last part, almost last part, deep learning methods. How does it work? We have the backpropagation, we have the layers, right? We have the loss function. Some of the methods, they have actually also the like autoencoders. They have many layers where actually they have the decoder and encoder part. So there are 2 networks combined together to generate data, for example. And in general speaking, as you can see, I know I ended here on 2015, but sure, it is advancing. So the percentage of classification on the ImageNet is actually the accuracy is growing, right? It's greater each year. So if you go into network, yeah, for example, this is an inception network. So explaining that is quite difficult, because just one of this piece looks like that. One of these blocks here, right? Looks like that. So and you have so many layers here. That's very complex to explain. You can imagine an actually inception network. Let me show you that. Here you have the model VGG16, which has 128 million parameters. So the weights that you need to be trained, right? So a lot. Inception is a bit more. It's not so complex. But that's another thing I want to mention. The complexity that doesn't always come with the accuracy, right? So sometimes, in many cases, actually, for example, inception network, it's a smaller circle here, means the complexity is lower than the VGG, for example, but it has a high accuracy because it's on the top. One of the methods to explain images, right, images using a deep neural network is the GradCam or the class activation map method, where actually we do a heat map and show how what part of the image has an influence, right? So let me show you that. This is the implementation of it, right? Here's the dog, the golden retriever, but you have also, for example, here the tabby, the Maltesian dog, and you can actually use any kind of image to find out, okay, what part of the image, and it makes sense, right? If when you take a look on the dog, here the ears, the eyes, here the chest, that's the part that actually is the most important to take a decision. Okay, that's a golden retriever. So that's where actually how you can explain even a deep neural network, right? All right, and the last topic that I would like to cover, I know I'm running out of time, but the last topic is the security, because that's important also when it comes to explainability. I mean, this is a separate topic, but when it comes to explainability, it can be easily combined. What you can see here, you can see, okay, two pandas, right? One on the left, one on the right. But actually, the one on the right is or can be recognized by a neural network as a gibbon. Gibbon is a type of monkey. Why? Because we add some noise that is not visible for the human being, but for the neural network, yes. Sometimes we even just need to change one pixel. This is one pixel here is marked with this red circle here, and it changed from a cup to soup bowl, from a bassinet to a paper towel, right? Of hamster to a nipple. That's just one pixel attack. And we don't want to understand how it works. Here you have more examples of such attacks, just to add some noise, to add some pixels, and changed from a viaduct to a window, right, or screen. From a dog to a rose. Depending on the attack, what's your target, you can change the images. Or a very also a classic one, where actually you can hide just by wearing this image on you. You will not be recognized as a human being, as a person. I guess you can even buy this kind of shirts on Amazon, just to hide against the neural networks. Just as a summary, criticism, right? When it comes to explainability, criticism. So try to find the hole in the try to find the challenges you have. Try to ask questions, like the MMD approach, where actually you try to say, okay, take some prototypes and then try, okay, why is it different? Why is it doesn't exactly like that? What's the difference? Why is that difference? How the model actually came to that, and so on. Also attention. Why I'm mentioning attention, I didn't set to so many. I mean, it had too many slides about attention specifically during the presentation, because it's actually more related. I mean, it is also related to the images or any other type of data, but specifically it is actually in the neural networks like GPT, for example, where actually attention is important, because it's a part of the model. But think about that, especially when it comes to neural network, and also the security, right? Secure the model. So explain it to make them secure. If you want to learn more about my talks, feel free to find me on YouTube. One of my TEDx talk about how to use machine learning for healthcare, for skin cancer. You can find YouTube. Thank you for now. I hope you enjoyed the talk, and if you have any questions, that's the right time to ask questions.
Karol, hello again. Thank you so much for the talk. And yeah, questions. We have a lot of them. So I would say we start right away. First one, more of a bit general question, but I'm interested in your expert opinion. What do you think will be the future of AI? What will be possible in the next 5 years?
Oh, that's I would say, I think that the right answer is it depends. And what really will change the AI, I think, will be the quantum computing. I don't think it will come in the 5 years, because it will change definitely the AI, the approach, and so on. It will change everything actually. If you will be able to buy a quantum computer, like going to MediaMarkt, or actually electronic store, and actually buy such a computer, that's the time when actually it will change a lot. For sure, the GPT currently there is a lot of hype around it, but we see many applications. If it evolves, it will also have an impact on us, right? On the way how we will live, how many things will be automated, and I believe it will go faster and faster now. I mean, hopefully we will not see the winter AI again, at least not soon. So in the next 5 years, sure, there will be evolving, but it's hard to really to say, because the big brands, they develop it mostly, right? The game changers.
Yeah. So sadly, no consumer quantum computers in the next 5 years. Sorry to disappoint folks.
Not yet.
But apart from what we have are more questions. So I would say let's move on to the next one. You mentioned classification, regression, reinforcement learning, but not recommender systems, which are very popular now, question mark. So why didn't you, I think, should the question be.
I didn't mention that. I didn't mention many other things, really, because I'm limited to the 45 minutes. Usually, when I really talk or actually want to train someone explainability, I do just a few days training on that. So I really try to limit the number of slides I had. By basic more than 80, I just limited to around 40. So it might be that I just missed that. Not for a specific purpose, just sorry for that. I try to make it better next time to extend that. But you're right. I mean, recommendation system is still some kind. It is. I mean, it's not reinforcement. It's more classification. Sure, I mentioned the classification methods there today. So I don't want to use it as an excuse, but well, yes.
No, you don't have to excuse yourself. It's hard to make everything that's trendy right now fitting into a one hour talk. It's totally understandable. So let's go on to the next question. What's your favorite AI project currently?
AI project.
Yes.
I'm now working on a coronary angiography. So that's a project where we analyze the heart vessels, and combine it with the ECG. So based on if you have a heart, right, it makes like tudum, right, something like that. And during this movement, there is a video during the coronary angiography where actually you record it, and we measure what is the quality of the vessels based on how they move. And second, we also calculate the blood that is actually pumped out of the heart automatically. Or I also published a paper, or I did a research on osteotomy. So I have many of actually now medical topics, this project that I'm just doing. So very, very interesting, especially that they have kind of a mission, like improving the healthcare system, improving the medical diagnosis to help people. Right, so that's this type of a project that I like.
Yeah, building things that help people, very nicely of you, and yeah, can totally understand why this is interesting. So, and we move on to the next question. We also need to eliminate underfitting, not only overfitting, question mark. Definitely.
With the unfitting, it is a bit I mean, I wouldn't say easier, but underfitting is very clear. I mean, you get just low accuracy with any kind of data. With overfitting, it is a bit more complex. The more complex model you have, it is also something that you can measure by changing the ratio of training testing data set. But it's more, in my opinion, it's a bit more complex to figure it out than underfitting. But definitely, I have another slides on to on underfitting, overfitting, and the right fit, how to get there, but I didn't had time to really go through. Feel free to ask, find me on LinkedIn. I can share with you the slides and then the code about that.
Yeah, or maybe for your next talk at WeAreDevelopers Live.
Sure.
So maybe we find also a topic in the next question. That is, when you mention security in machine learning, what do you think about GANs and fake videos?
Well, fake videos, I guess you mean, generating videos, right? That, or actually, changing the face or changing the voice, for example, in the video, right? To be considered as something different that it used to be. Well, what can I say? That's where actually you see machine learning, as one of the application. When it comes to security, you cannot really secure. I mean, you cannot secure specifically on that because it's like, if someone buys an iPhone or a mobile phone, you cannot really secure for sure that someone will not break, I mean, at home into this phone, because it's just very, very hard to do. But there are some ways how to secure your videos or your content to be secure when it comes to the, let's say, adding or changing it. One of such is actually the watermarking method. In videos and images, it's quite easy to do. Even if it might be also watermarking that it's not visible for the human beings, like the example of the pandas, right? So you can do that, or now very, very, very trending topic, the watermarking in NLP and text generation, because we have GPT, right? And how to secure your text that it will not be really stolen or taken or changed by a model like a GPT or something like that. So that's also a very interesting topic that is now evolving. So the researchers are finding new and new methods, but we are still somewhere at the beginning here. Sorry for talking too long on that.
Oh, no, you didn't. Thanks for this answer as well, Karol. And let's go on to the next question. Are there some ethical considerations related to explainable AI, especially in sensitive domains like medtech and fintech, to keep track on?
Yeah, definitely. Definitely. As you saw, one of my slides, we have the gorilla. I mean, the image that was recognized as gorillas. That's ethical problem, right? That's an ethical problem, definitely. Or the Thai tweet bot. That's definitely an ethical problem, right? Yes, explainability is about to help, right? It's also called responsible, right? Responsible AI. Also, just to handle the ethical terms. If you don't know how your model works, then it's hard to talk about ethics, right? If you know how it works, or at least you are to some degree able to explain that, then you can talk about ethic and actually change it to be more ethical. That definitely that's part of explainability.
But thanks for that answer as well. Karol, you have an academic background and you actually co-founded your own company. I would be interested, how did you become interested in tech in the first place, and what was like your developer journey to the point where you are?
I started with the Commodore 64. In 1992, I started developing. I know I'm 40, right? So I started with BASIC as a 9-10 years old child, and then at 14 more or less, I started to learn on a PC already assembler language. This was my first real language that I picked up by choice. Just to understand how it works under the hood, how the CPUs works, how is the memory moved here, there, and so on. And then after that, I just moved to to some other higher level languages, and finally ended with machine learning. In 2007, I started my PhD. In 2005, actually, I started also doing some work, but 2007 is actually where I really started doing the machine learning for real applications. So it's, I mean, I don't want to go into details too much, why I use assembler, what I did in BASIC, but yeah, more or less that's how it went in my case.
Right, and then you just said like, now it's time to found your own company and make your interest like to your profession.
Yeah, with the company is a bit, it's a bit, there's another story, because I founded my company because I resigned from a full-time employee because I couldn't actually combine it with the PhD studies. So I said, okay, to do a PhD, I just need to be more flexible. I will just open my company. And now we have 400 people, right? And I did a PhD, so
As easy as that. It sounds so easy when you explain it. Awesome. Hey, Karol, thank you so much for the talk, also for the Q&A, and for sharing your story. I wish you a nice rest of the day, and hopefully see you soon on another live event for us.
Thank you very much. Thank you for the invitation, and yeah, hope to see you again on the conference. Thank you.
Have a nice one. Bye.
Bye-bye.
All right, and before we jump to the second speaker of the day, just a 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to machine learning. And the second speaker of the day, he is technical evangelist at SingleStore. He already had a variety of roles, such as developer, consultant, evangelist, and technical writer. Has several academic grades, including a PhD in computer science, and he's a member of the British Computer Society. Welcome, Akmal.
Thank you very much, Benny. And
thank you so much for joining. Quick side note, you can already share your screen, so we can make the transition later.
Yes. Thank you. So I was listening to Karol there, and he was saying that he used a Commodore 64. Well, I can trump him before that. I used the ZX80. So that's even simpler than the, going back even further.
Yes, but two legendary systems. So really a gathering of the heroes of old times, you might say. All right, Akmal, before we start with your talk, would you mind sharing a bit with us what we are going to learn from you today?
Yes, absolutely. So what I'll do is we'll talk a little bit about WebAssembly, but you don't need to have any background or experience using WebAssembly. You may have heard of it. And I think over the last couple of years, we've seen some development of this technology, particularly with web browsers. And you may have come across its usage in that sort of context. So the focus today is to actually, how can we apply WebAssembly to a database management system, and what sort of benefits could it bring? And this is something that I think in the past we have seen similar sort of initiatives and efforts. So taking libraries, if you like, and having the ability to extend the capabilities of a database management system, but it's not always been very successful. And I think particularly with WebAssembly, because of its wide adoption and usage now, and stability in terms of tools and development techniques around it, it really offers a lot of promise. And the example we'll look at, which I'll show you some code and some queries, is for sentiment analysis using something called VADA, Valence-Aware Dictionary and Sentiment Reasoner.
That sounds very interesting, Akmal. You got my full attention, and that of the audience also, of course. And I would say, without further ado, the stage is all yours.
Okay. Benny, let me start the slideshow, okay? And you let me know if there's any problem if you can't see it.
Yes, we will.
Okay, great. There we go. Okay, so just double check that I can use my... okay, there we go. That's great. So using WebAssembly for in-database machine learning. So as I mentioned, the WebAssembly is something that you may have come across in the recent past. And I heard about it originally in the context, again, of being able to run code within a web browser, take some C++ code, for example. And more latterly, there has been interest from a number of database vendors, of which SingleStore happens to be one. So there are others as well developing this technology for use within database management systems. So it offers great promise, I think. And so we'll look at an example today. Okay, so as Benny was saying, I work for SingleStore, and actually I'm coming up to my 2-year anniversary, almost to the day now. I think a few more days, and it will be 2 years that I will be with the company. So in terms of the agenda, just a short introduction, look a little bit about WebAssembly and some of its context, how we might want to do machine learning with a database management system. There are a variety of different options, and especially today, we see the development of these so-called vector databases as well. So if you're using things like OpenAI, embeddings, for example, this could be very interesting as well. Most of my time will describe the setup process, how you could install the software for doing, WASM development. And that's a one-time operation, okay? There will be something specific to SingleStore, so most of it I will try to keep as vendor neutral as I can. There will be something specific to SingleStore in terms of a tool that we will use once we've built a WebAssembly module, how to load it into the database management system, and then we can actually use that within the DBMS. And the DBMS treats it just like it's a standard UDF, no different, okay? So we'll take a look at that. So there'll be some simple queries that we can run, but equally, I thought it would be much better, for example, to do, using this large movie review data set, which is very useful. And we can take a look at that and how we can apply WASM to that. Okay. So just one slide on SingleStore. So what we've seen, I guess, over the last decade and a little bit more is really the emergence of a lot of these distributed database management systems, of which NoSQL, was great in terms of the direction it went through, the multi-model, the document stores, wide column stores, key value, graph databases. And something that these systems brought was this ability to really exist in a distributed manner. So if you look at the systems such as Cassandra, for example, very robust distributed sort of capabilities. And this is something that with relational database management systems, we really didn't have in the past. I mean, if you wanted more power, basically you scale up, get a bigger box. With the advent of NoSQL database systems, it was really a case of scale out, horizontal scaling, take off the shelf hardware, being able to scale up. And this is then something that kind of made its way into the relational world. So now we have the development of a number of these distributed SQL database systems that take advantage of this kind of distributed capability. And if you think about it, in the relational world, I mean, relational systems can be distributed quite well. I mean, if you look at a relation, a table, I mean, you could split it horizontally or you could split it vertically. And that's a good way to be able to distribute your data. So there's one mechanism there. So today, I guess there's about half a dozen fairly well-known distributed DBMSs out there that use relational as its kind of backend. And SingleStore happens to be one of these systems. Okay. My background is that prior to joining SingleStore, I actually worked for Databricks as a technical instructor. So I got to use Apache Spark firsthand. And it's an awesome technology in terms of scale and working with big data. but it also comes with some very nice libraries as well, such as mlib, for example. So that is one mechanism that you could use, especially if you want to work at scale in terms of doing machine learning. You could potentially store most of your data in a relational database management system, for example. Could be MySQL, Postgres, could be one of the larger vendors, might be SingleStore or another vendor's product. And you can integrate quite well with Spark. So Spark can do some of the heavy lifting, for example, and it can utilize the backend system in terms of its intelligence. So it does this kind of push down as well to say, well, you, the backend system, you know more about the data, here's a query for you, you go away and evaluate it. And that can be very, very useful as well. I'm sure many of you have worked with a lot of these Python libraries. I particularly like scikit-learn, for example, which is awesome to use, comes with some small built-in data sets. And especially, I think, if you're working in the Python environment, I think that's a great way to get started. But again, fairly easy to be able to integrate something like that with a relational system. I mean, there are JDBC drivers. You can connect to a database management system very easily. Specifically today, there are, our focus is going to be on this Veda is the example that I'm going to use. So in terms of WebAssembly. However, I did mention just a couple of minutes ago this concept of vector databases and vector functions. So, SingleStore just happens to have some of this capability built in, and it's not something recent as well. I mean, it goes back in time a few years, from about 2017. So things like Euclidean distance, dot product, for example, these are built in and very useful, particularly in the context of the last option here, the OpenAI, which many of you may be using. This has taken us all by storm. It's come to the fore very, very quickly. And it's a great way to be able to take some data, create these vectors, these embeddings, if you like, and be able to then store these in a database management system, of which there are some of these vector products that are emerging, and then be able to query that and be able to get back a kind of a score, if you like. How relevant is that? There you're looking for semantic matching, if you like. That can be very, very useful. So there's a variety of ways to utilize a DBMS in this context, and all of these things can work well, depending on what you're trying to do. Okay, so specifically then for WebAssembly, what does it give us? Well, historically then on the left-hand side here, you can see, this is the kind of the way that we would tend to build things. Basically, we build an application and then we would tend to target a specific application platform, whether it happens to be Android, for example, or Linux, or so on. That becomes cumbersome. Essentially, we've got multiple targets that we need to think about, and then all the idiosyncrasies about those different platforms. Wouldn't it be easier if you could do something like this? On the right-hand side, essentially this kind of write once, deploy anywhere type of environment. Take your application, convert it into WebAssembly, and then you just have different runtimes for the environments that you need. This kind of, go back in time and think about Java, for example, this kind of write once, run anywhere type of scenario and environment. And really, we can achieve this with WebAssembly. So today, our focus, it's not on the list here, but you can see that we potentially have a number of options. The web is an obvious one because really that's where it started. But I could equally run it on the server where I may have a database management system running as well. Okay, and the example we'll look at today shows us something in that direction. Okay, so what is the reason that we might want to use WebAssembly specifically with the database management system? What are the benefits it will give us? Well, sometimes it is actually hard writing procedural SQL. Think about some of these SQL queries that you come across from time to time. Very, very complex, and really require a lot of detailed knowledge about the workings of SQL and how to formulate that query. Equally, there may be situations, for example, where the DBMS does not support some particular capability, and we would like to extend its ability to handle something such as machine learning scoring, for example, or fuzzy text matching. There is this concept of co-location, which is very, very useful as well. Why move lots of data around take it out from the database management system to the application just because you happen to have the algorithm in the application rather than being able to run it within the database management system. Wouldn't it be a good idea if we could execute the code with the data co-located without having to shift a lot of data around? So that's another benefit that we can get. And sometimes actually the coding query logic in the application takes lots of developer time. And there are things that sometimes we are asked to do in terms of the sorts of queries that we need to formulate. Again, requires some knowledge, some expertise, some skill. And then today with the development, if you like, of a lot of us want to do kind of data science type stuff. We may not have the skill or expertise to be able to do that, but something like WebAssembly may be able to assist us in this space. And here's the kind of general architecture of how we might approach this. So regardless of the language, so here you can see a couple of the languages that are popular and supported. So C, C++, and Rust are the languages kind of in the pipeline. And again, this is not unique to SingleStore, but you will find other vendors doing similar sorts of offerings and interfaces and APIs, and being able to compile into WASM. But essentially, what we're doing is taking some code. So we may have some existing code, some existing libraries that we built over a period of time, and they may have some useful business functionality. We can now take some of that code, okay, with care, right? Because not everything is going to work within this environment. It is sandbox, therefore there will be some operations that are not possible. But we could take some business logic, for example. We could wrap it up into a WASM function, have that function stored within the database management system in a sandbox environment, and then we execute that code in a safe and controlled way. And that gives us the ability to kind of in the United States, they say leverage, take advantage of that code. It still has some value, and we can still utilize that in a business context. The other benefit that we get is, again, we take the code, and now because we are storing it within the DBMS, this co-location comes to the fore. And especially within a distributed environment where you want to try and avoid a lot of movement of data, having the data and the code stored close together gives us great benefits again. So at a very high level, again, here you can see we take the source language. So today's example, we're going to focus very much on Rust. All we need to do is to simply build it and load it into the DBMS. And as far as the database management system is concerned, it will treat it as though it's some kind of UDF. And we have this safe kind of sandbox environment where the code actually executes. Okay. I've seen this kind of notion of wanting to execute code within the DBMS ever since, forever. It's a long time ago when I started in IT. So that idea and that notion has been around for some time. And many, many years ago, I remember Mike Stonebreaker, who used to be my boss. So Mike is a legend in the database world. I mean, he's the guy who invented Ingress, Postgres, Vertica, SciDB, VaultDB, and so on. Mike talked many years ago about this idea of creating these kind of libraries, if you like, and then having them execute within the DBMS environment. And there's a kind of a trade-off. Do you want great performance, or are you prepared to allow that code to execute in the same space as the database engine, which, if there's a problem, it could bring the entire system down. So that is something that's been talked about for some time. But here you can see in this environment, very much so, we have this notion of a sandbox, which gives us some protection and safety. And that really, I think, with the benefits of speed as well, running things at near native speeds. Okay, so let's just walk through the steps that you would need to do. So remember, I mentioned a few moments ago, this is a kind of a one-time operation. Okay, so once you've done this, unless you want to update the SDK or the particular software environment, this is pretty static. You can use this, set this up, use this, and update the software at some point in the future if you want, if it's necessary. But certainly this is very, very easy to do. Easiest thing to do, what you start with is the WASD SDK. Okay, first thing to do here. And this is available from GitHub. Okay, and literally you need to do just a couple of steps. Just download it, and in this particular case, it happens to be version 20, which is actually the latest version that's available. And here you can see it's for the Linux environment. You can download this for other platforms as well, such as Mac, for example. Unpack it. There is a bin directory. We simply export and add that to the path, and that's all we need to do here. Okay, so literally this is the kind of the core, if you like, of the environment, this SDK. Once we have this, the next steps are fairly easy. In this particular case, because we're going to be working with Rust, there is a Rust toolchain to install as well. Again, very straightforward, one-liner there you can see, and then we just need to source this to ensure that we can access this correctly. And the last thing we need to do here is this with bindgen. Again, from this, you can see this reference here to the Bytecode Alliance, okay, which I'll show you a little bit later on, show you their webpage. It's worth keeping an eye on what they are up to, okay, because the number of organizations are part of this, kind of developing standards, very interesting stuff going on there as well. So if you want to keep your eyes on what's happening in that space, I mean, definitely follow that. Last thing, again, specific to the Rust environment, is just adding this WASM32WASI to the Rust toolchain because it's not installed by default. And that's it. I mean, that is entirely vendor neutral. That has nothing to do with SingleStore. So once you've gone through these couple of steps, install this in your environment, you are good to go, and you can start working with Rust. Equally, if you wanted to use, say, C or C++, I mean, obviously, make sure you've got the appropriate tools for that. Again, reach out to me afterwards, and we can work through that, and I can help you if those are the the tools that you would prefer instead of the Rust, which we're going to go through today. We take some Rust code. We need to compile it. Once we've compiled it and we have a WebAssembly module that exists within our environment, we need to upload that into the database management system. Each vendor will have their own particular offering in terms of how to do this. SingleStore has this repo on GitHub called pushwasm, which literally it does what it says on the tin. So all we need to do is just clone it. We just build it again, cargo build release, and then again we just add the path for where the tool gets built to our path so that it can pick that up as we run it within our environment. Okay, this does require this libSSL. Okay, so I find periodically, because I use a virtual environment mostly for a lot of these demonstrations, simply because it's a nice self-contained environment. It doesn't depend upon my host. My host tends to be very in flux all the time. Things get installed, things get removed. Sometimes that causes difficulty, but having a clean environment, sometimes you miss something. So the libSSL is required because you do need a password to be able to connect to the host database system in order to be able to upload your WebAssembly there. And that's all we need to do. The next step is just to build our code, and so we just create a directory. Okay, make directory here. Very straightforward. And if you're familiar with Rust, here, this one-liner will just give you the skeletal Rust source tree, and it will give you, a source folder and a couple of other things within that environment. We need next to create what's called an interface definition file. So our function is going to be called sentiment table. Okay. And what we're going to do is we are going to create an interface definition file called sentiment table.wit. And within that, literally, it's just a text editor. So all we are saying here is that our function here, okay, sentiment table, it takes a string as an input here. And what does it return as output? It returns a list of these polarity scores. And what are these polarity scores? They are defined just above here, okay? And you can probably guess what these are by the names, okay? So we've got positive sentiment, negative sentiment, neutral, and this thing called compound here. So the compound is just the positive plus negative plus neutral, and then normalize that between -1 and 1, and that will give you the compound value. So this is just the interface definition file, okay? And again, if you've worked in the past with other technologies, here I'm thinking about Corba from many years ago, which used to have this concept of interface definition files as well. Essentially, we're just describing what we are building here. What are the inputs? What are the outputs? And we're, simply putting that into this WIT file. This is not the actual code. The Rust code we'll get to momentarily. Okay, the next thing, cargo. This is the package manager for Rust. Okay, so again, we need to put a few dependencies in here. So the WIT bindgen, remember I mentioned that a couple of minutes ago. Here, we reference this. Bytecode Alliance, okay, remember that name came up a few moments ago. And then specifically here, this piece of code is what we're going to use. So someone has very helpfully taken this VADA, Valence Aware Dictionary and Sentiment Reasoner. Originally, I think it was written in Python, I believe, but here it's actually been converted. There is a Rust version of this, if you like, and this is where it resides, and that is what we're going to use. So we're going to utilize a library that somebody else has built. And again, this goes to this idea of reusability, okay? I mean, why rebuild or reinvent the wheel? If someone else has done this for you, you can utilize that and be able to take advantage of that in this environment, okay? So this is just giving us a little bit of information, telling the system what we're going to use, and we are going to utilize something that's already available to us. And then finally, just the Rust code. So the Rust code is very, very simple. Now, because there's a little bit more than one slide's worth here, so I've had to split this. But again, what we are simply doing is defining the actual function here, okay? Sentiment table. We are saying that it takes an input string and it returns a vector of these sort of polarity scores here. And then specifically, we are able to call that VADA sentiment just here. Okay, so this is the library that we kind of referenced in the previous slide. And then finally here, again, you can see that this is quite familiar, the polarity scores that are being returned. Okay, so the compound, the positive, the negative, and the neutral. And that's all we need to do. Okay, so we just need to build that simple one-liner command. Okay, we've got all the SDK and the installation that we previously done. We're now able to use that. Release to make sure that the code is optimized. Okay, that helps to keep the size small. And then what we would need to do is just connect to our database management system and then just create a database that we can use. In this case, I'm just using a MySQL client here, okay, because SingleStore is MySQL wire compatible. So this is just running in my local environment. For the demo that I'm going to show you momentarily, I have a 2-node cluster that I have installed within a virtual machine environment. And I just connected to that using this MySQL client. And what I did was a few moments before we started earlier today, I created this database called demo. And we're going to use that. So the code is compiled. My WebAssembly function exists. What I need to do then is to upload this into my DBMS. And this is where this push WASM tool comes in. Now, it looks like a sort of very busy command here. It looks like quite a lot is going on, but let me just talk you through this. Okay, so again, what we're simply saying is take this particular function whose name happens to be sentiment table. Here is the location of the interface definition file, the WIT file that we built. Here is the actual compiled code that we've created that exists within that subdirectory of my working directory that I created. This is the detail of the connection, okay? So obviously you'd slot in the appropriate details for host here, for example. Okay, if it's local or if it's remote, however you want to use it. And then the prompt is simply saying that, prompt me for a password. And so once I do this, it should momentarily come back and say WASM function was created successfully. And now I can just use it straight away. So 2 quick examples to show how I might want to do this. So the very first example here is just a select statement. So all I'm saying is select star from sentiment table, and then I'm passing in this string. And the string is saying the movie was great. And what it's doing then, it's returning this table. So it's giving me various values. So based upon the string that I've given it, it's kind of assessing that and providing some values for the positive, the negative, and the neutral. So it's come to the conclusion that there's nothing negative there. Neutral seems to be fairly strong, even though, I said it was great. So positive is again sort of fairly average. And then we've got our compound score over here. One of the things about Veda is that it can consider things like emojis, for example. In this case, we're not using them, but other things that it can consider is that if you use like capitalization to emphasize something very strongly. So in the second example just below here, I've got the same thing here, select star from sentiment table, and I'm saying the movie was great. But notice here that the word great is in caps. And also I have an exclamation mark at the end to make even sort of stronger emphasis that I really, really like this movie. And so in this case, if you look at the numbers, you'll see that the neutral value has actually gone down. It's now 0.369, whereas previously it was 0.422. The negative is still 0. The positive has also gone up. Now it's 0.6307, whereas previously it was 0.5774. And again, the compound value has gone up as well. So it is actually very, very capable piece of software. Again, I'll show you the web page where you can access this and read the documentation on this. But this is very useful in the sense that it gives us a lot of insights into the data that we have and allow us to analyze that. But let's now take this a step further. So I'll exit from here, okay, and just show you something actually running within my environment. So let me just switch here to my virtual machine. And again, Benny, let me know if you can't see anything, okay? So it's a new environment for me. So I just want to make sure I don't, I'm not typing away something and no one can see it. So thank you. Okay, so as I said, I've got a virtual machine here. I'm using VMware Fusion. And within this environment, I have a small cluster. It's 2 nodes. I have a master aggregator and a leaf node, as it's referred to in SingleStore. And what I've previously done, all of the steps that I showed you within the slides in terms of building the WASM module, and all the Rust code, the cargo, the WIT, and then just using the push WASM, to push that code into the database management system. I've gone through that. I've also loaded the large movie data set into a table, so I can show you that. So this is okay. So we have this demo database, use demo, show tables. Okay. So we've got this table called IMDb reviews here, and we can take a look. Let's just clear this and say describe IMDb reviews. Look at that. Okay, so you can see it's very simple, just 2 columns here. I don't actually need this this column here in terms of the sentiment. The top one is the one that I need. Let me just try and get my arrow here. This thing called text. So that actually contains the sentiment, if you like. That is the review that moviegoers have said. So, they've commented on a particular movie, whether they liked it, disliked it, or whatever the comments happen to be. And if I say show functions, you can see here what does the database and I apologize for the wraparound there because the size of the text is a little bit large. Unfortunately, it's wrapped around a bit. But essentially, what it's saying here is that it knows about this function called sentiment table. Okay, it happens to be a table value function. The reason for that is that you saw in the examples in the slides when I was saying, you know, the movie was great, in caps, exclamation, it returns a table as a result. I mean, that is the value that we're getting back. And then in the last space down here, the runtime happens to be WebAssembly. So the database management system is aware of this function. It can use it now, and I can treat it as though it is any type of UDF. So again, let me just clear my screen there, and I've got a command prepared here. Now that looks quite busy. The substring is simply to condense the output. Otherwise, it's going to be too much. So that's all that's happening here. I'm just limiting the output that's going on. But here is the actual sentiment table that we're calling as part of that. And I'm just limiting it to 10 rows. So if I run this, you can see now that it's applied that function to all of the data within that table. It's giving me back just 30 characters of text here, okay, just to keep it short so we can see it on the screen. But there you can see, pardon me, we're getting the compound result, the positive, the negative, and the neutral. And it's evaluated that for every single row there and returned these 10 rows back. So very, very straightforward, as you can see. So again, the benefit here, as you can see, is that the code is now running within the DBMS environment. I have encoded it to do this sentiment analysis for me. There is this co-location, which is very useful. And as far as the DBMS is concerned, it just treats it as a user-defined function. And in theory now, if you think about it, I mean, this example happens to be sentiment analysis, but there's other types of machine learning operations that you might want to run, for example. And even, if you don't particularly use Rust, for example, or don't have a lot of experience with it, other languages that you can use, C, C++, I alluded to a little bit earlier on, but other languages are being developed as well, if you are more familiar with those. So this gives you a lot of freedom and flexibility. And as I said before, there's a range of vendors that are providing support for this capability. And this, I think, could be very, very useful going forward in terms of how we do machine learning on data stored within the database management system. So no need to do ETL, no need to export the data out, to use other tools and technologies, and then take the results from there. Now we can keep the data where it is and be able to run these machine learning operations upon those to get useful insights into our data. Okay, let me just go back here and just wrap up then. So WASM, WebAssembly, okay, you may see those used interchangeably. So these UDFs give you a lot of power, great deal of extensibility. Essentially, you're no longer limited now to what the database management system gives you in terms of features and functions, but you can extend its capabilities almost endlessly, I would guess you could say, with care though, because remember, it is a sandbox environment. So there will be certain operations that you won't be allowed to do. It's going out of that environment, reading and writing from the file system, for example, those won't be allowed. But you can do so with, hopefully your favorite language. We saw the example using Rust today. C, C++ happen to be also supported within SingleStore. Other languages are coming along as well. It's fast, giving you almost near native speeds, and it's safe as well. Okay, so I think these are sort of key characteristics here. Okay. Now, I've walked through this example, and so actually last year, around about October time, I wrote an article about this. So all of these steps that I've described are contained in an article that I published on Medium. So you don't need to, pardon me, it's not something that you'll find difficult. You can just simply follow the steps there. And then again, the Bytecode Alliance is something to monitor and check on. They have useful tutorials there. There's a number of major vendors that are part of that. And there we go. Thank you. And just before we finish, so let me just show you. So this is the crates.io. So this is the Vader sentiment. Okay, so as I said before, there's lots of useful information here. It tells you much more about how to use it. So remember I mentioned this, that it can handle emojis. So there's a little bit on emojis here, for example. The fact that you can emphasize, provide some signals, if you like. So things like caps, exclamation marks. It can pick up these signs to ascertain that, yes, you are particularly strongly emphasizing something or not. And that can be really useful. And this is derived from some original work, which is available on GitHub. And there we see the reference here if you want to do the citation. Okay, so this is where the original content was developed. Here's the article on Medium if you're interested. Okay, so you can just search for my name on Medium, and this will again just walk you through the steps. The only slight difference between this published content and what I've shown you today is that the push WASM tool, the syntax has changed slightly in continuous development. So I may go back and fix that in my article, but it's not actually a very big change. I mean, you can see from the GitHub repo, there is a README file which will show you. And then this is the bytecode alliance. So again, very useful to monitor what they are doing in terms of standards. So you can see all the sort of major vendors there, familiar household names that are part of this effort in terms of developing standards around this space. Great. Well, thank you very much. And I'll stop sharing that now and hand back to you, Benny. So if you want to...
yes, I want to. Hello again, Akmal. Thank you so much for the awesome talk. For starters, you showed us lots of websites now in the end. Would you mind sending us the links in the private chat?
Yes, absolutely.
I'll do that.
Yes.
We can just share them in the public chat with everyone, so everybody has the shown resources. It would be awesome. All right. Yeah, in the meantime, we also got some questions, but let's just wait for the links so we don't mess up.
Do you want me to? Let me take this whilst we are just waiting for those. And should I just post it in the comments? Wait. Or should I just send them to you?
In the private chat.
Okay, so, I apologize. There we go.
All good.
Can you see that?
Yes.
Okay, great. My apologies. This is new software for me. I use Chrome and Zoom and lots of other things. So my apologies. I'm a little less familiar with this, but let me just share these with you, Benny, and then it'll be a little easier for you. Bytecode Alliance. So this is great for standards, as I said before. Keep an eye on what these guys are doing because this could have a strong influence on what's going on. So I think those were the three main ones that I showed, Benny. Yes. And in terms of the SDK and everything, I mean, those will be in the slides anyway, and the references to them in the Medium article, that contains everything as well. So rather than overwhelm you with too many links, I think those three.
With these links, everybody should be good to go. All right. And talking about good to go, let's go on to some questions, I would say. And maybe as a first one question, Akmal, do you have some real-world examples that demonstrate successful implementations of WebAssembly for in-database machine learning?
Okay, that's a great question. My role is a technical evangelist. Basically, I tell people how awesome technology is, but I work much less with customers. I'm of that. I mean, you can see the lack of hair and the gray hair. So I in my life, in my IT career, I mean, I've been there, done that, got the T-shirt. So I used to do consulting work, and I actually enjoy working with customers because at the end of the day, what I see is that technology is just an enabler. It's it's just a black box sometimes. It helps solve a problem, but it's far more interesting to hear what customers are trying to do in terms of the actual problems that they want to solve. And so, if People are interested. I can certainly find some examples. Off the top of my head, I don't have any. I apologize, okay? But that's a great question, a great one to put me on the spot with. But I think we do, broadly speaking, as I said, this WebAssembly is being supported not just by SingleStore, but a range of other vendors as well, both in the relational and non-relational space. And so I would encourage people to just look at your favorite vendor's website and see what they are doing in this space. They may well have case studies, customer write-ups, white papers describing particular scenarios where this is being utilized. But fabulous question. Thank you very much for whoever asked that. And I'm sorry, I haven't got a great answer for you. No, but I'm a technical guy. I'm not a marketing guy, so I'm sorry.
That's a good call to action. It's not always good to rely on just one talk.
Yeah.
Even if it's as awesome as yours, do your own research. So yeah. But next question, you already said that you can use many languages with WebAssembly, but we have one in particular who wants to know, can we use Python for WebAssembly also?
Yeah, I think Ben, if you remember in the slides early on, I showed an architectural diagram which showed C, C++, Rust, and Python was kind of in dots. There were dots around it.
Okay.
And I think there's been an issue in some of these dynamic languages. I think that I've had people contact me and asking, is there Java support, for example? I used to use Java a long time ago, and a couple of years ago, I did a presentation again on WebAssembly. Someone asked me this question, and unfortunately, I think Java at the moment is not receiving very good support in this space, simply because I think the focus is on other languages right now, which are kind of easier to implement. I believe Python support is in the pipeline. It may be that, again, your favorite vendor has that support already available. Certainly, as far as SingleStore is concerned, again, it's on the roadmap. It's coming, but I can't give you a firm timeline. But again, call to action: check with your favorite vendor, see what their level of support is currently. It may well be that they have that support right now.
Or maybe on your next talk, on the next live day, you tell us on how awesome Python performs in WebAssembly.
Yeah, that's a great question. I think the challenge is, Benny, that and there is a wonderful website, which unfortunately I don't have the link to right now, but I can send it to you later. It's a GitHub repo, and it's got a list of all of the languages that the author knew at that sort of point in time where WebAssembly support is being developed. And it's a huge list. I mean, all of the well-known languages are there. And there are links to various resources that show how good or bad that WASM support is. And unfortunately, some languages are much better supported than others. So I think simply because of the nature of where we started, we want to have this sandbox environment. Using compiled languages is a lot easier than dynamic languages. So initially, the focus was just on that space. But equally, people want to use their favorite language. They don't want to be constrained to a small subset, and therefore the work is there, it's in progress, and it's coming along. But again, I think there are technical challenges as to why it's taken so long. That's the only thing I could say. I mean, that's my understanding of it and my assessment of it at the moment.
All right, then let's wait what the future brings.
Yeah.
And until then, I would say we go on to the next question.
Yeah.
Performance-wise, how does WebAssembly compare to traditional approaches for running ML algorithms on a database? Are there any benchmarks or metrics that you would recommend giving a look at?
Okay, that's a great question. So as far as I'm aware, with the WASM that we have, it will run at near native speed. So if, for example, let's say you've got some C or C++ code that you've compiled and you're building and you're running it outside of the DBMS, within the DBMS, it will run at almost the same speed. I mean, there is going to be some slight hit and trade-off there, but you're getting very good performance there. Now, remember, the example that I showed you today focuses specifically on machine learning, simply because this is a machine learning track, and therefore, that's what the demo is about. but conceivably you might be doing something in the non-machine learning space. You might be doing something else, some other algorithm that you're implementing. And I believe the performance will be as good in the database as it is out of the database, with the exception of what I said just a few moments ago, that obviously because it is a sandbox environment, there's going to be a small hit that you're going to take. Beyond that, I'm not aware of any benchmarks or tests that have been done to compare in and out of database performance. My guess is that probably the in-database performance is going to be as good, because yes, you're taking a hit in one space, but think about it. What is the benefit that you're getting? You're getting that co-location, so there is no data movement. The DBMS is kind of optimized for certain operations. So yes, it treats that UDF as WASM UDF as a black box, because it can't look inside and look at the implementation. It cannot optimize that anymore, but we've kind of built the code outside and we've uploaded it. So the DBMS can certainly take advantage of all the knowledge it has beyond that. And my guess is that, in database performance should be as good as it is outside. So whatever algorithms you're running, whatever piece of code you're running, that's my assessment and my guess. Now, would that same rule apply if you were doing like hundreds of terabytes of data? That's a great question. If you're doing machine learning on hundreds of terabytes of data, you really want to think carefully about that. I think that's not the right thing to do. Probably you want to take smaller samples of that to build your models. I mean, generally, that's what I think good data scientists tend to do. But machine learning benchmarks, so far, I haven't come across any, not in the WASM space. So difficult. Again, great question. Thank you for these hard questions. Okay, so, it gives me great things to go away and sort of research and find out about, and that's one of the benefits of having an audience. They'll often think of things that I, as a presenter, would never think so.
Yeah, it's always nice to be challenged and to be confronted with things you wouldn't have thought on yourself. So
yeah, great. So, yes,
kudos to the audience for all these good questions.
Thank you.
All right, and we go on to the next question. Sorry, I was late. Can you explain how a machine learning classifier can be ported to a WebAssembly module? Also, is this recorded? The last part I can answer yes. And now to you, Akmal.
Okay, thank you, Benny. Yes, so essentially, I mean, you're taking some existing code, and it can be in a variety of different languages. And so you're simply, I mean, today we looked at Rust as the example. So we downloaded and installed some specific tool chain for Rust, and our code was in Rust. But the thing is that the interface definition file that we created, that is the same for if you're doing it in C or C++, for example, or another language. That doesn't change. And the kind of the process, the mechanism that you use in terms of building the code is the same. So at the end of the day, I mean, you will get a WASM module built regardless of the language that you start with. So if I'm using C, C++, or Rust, I will end up with a sentiment table WASM module. In the example that we use today, it's Rust, so it will upload that. And as far as the DBMS is concerned, it just treats it as a UDF. It doesn't look inside it to see what's the implementation. It's just binary, okay? I mean, there is a sandbox environment where that code executes. So the process is very, very straightforward. It's a couple of steps just to create your development environment, depending on what particular tools or languages that you want to work with. If it's C, C++, or Rust, for example, or something else, make sure you've got the appropriate development tools there. Now, today you saw me using the CLI very much. I didn't use an IDE or anything like that. Potentially, that's something that I could do. But once the interface definition is defined, once I've built the code into a WASM module, the steps from there are the same, regardless of the language that I used, in terms of simply uploading that into the DBMS environment. And as far as the DBMS is concerned, just treats it as a UDF, and it will just run it. Although it does have a little bit of knowledge about it. You saw me do the show functions command in my virtual environment. So it does know that it is not native to it, but it is a piece of WASM code.
Right. Akmal, thank you for that answer as well. And as a quick addition to my short yes answer to is this recorded, you can watch every talk by the end of the week in our watch section on WeAreDevelopers.com. All right. And Now let's move on to the next question. You get next is not entirely a question. It's just kudos to you from Emma. Thank you, Akmal, for your presentation. I see he loves sharing knowledge.
Okay, thank you very much. You get to a certain point in life where it's great to learn new stuff, and we live in an age, I think, where things just move in leaps and bounds. So the example I often give is that I started my IT career a long time ago, which you can tell by the hair and the lack of hair. In those days, the world didn't seem to move very fast, or at least it seemed to me. My career started as a developer, and I could probably have stayed in the same job for like 3, 4, 5 years, and the outside world didn't seem to change very much. I think open source has really done a lot over the last 10 to 15 years. Lots of developments. I mean, it's very difficult, in a sense, for the developer, it's quite a challenge. I mean, he or she faces a dilemma. Which of the half dozen or dozen technologies of the hundreds that are out there should they learn today so that they are well placed to take advantage of those in the coming months and years, in terms of their career development and the next opportunities that they see? It's very, very difficult. Currently it is these GPT type technologies and embeddings. Who knows? A year's time, something else will hit us in terms of a wave. So I would suggest, keep your eyes on what's happening, monitor. I mean, and this is why this type of conference and these type of sessions are so helpful, because you get to learn a lot from people, and I get to learn a lot as well. So some great questions today, which has given me some ideas into go away and do some research on some topics. That's great, and it helps me as well.
Yeah, that's some great advice. And to the audience, if you want to learn more also about the topic, we have, as already mentioned, on wearedevelopers.com/live/videos, we have lots of previous talks stored for you. So if you want to go further into these topics, just check them out. And we, Akmal, go on to the next question.
Yep.
We heard about pros of WebAssembly. But what are WebAssembly cons?
Okay, so pros and cons, yes, absolutely. So I think from watching this presentation and seeing how I did the development, you can see that in a way it's rather cumbersome. Okay, so to download the SDKs, configure the environment, everything is very manual. There is no kind of automation there. So I did that specifically for Rust today. There's no IDE that I used. I mean, what is the integration for WebAssembly development within IDEs? I think that would be really helpful. It's a kind of very slow and manual process that I went through, and I would say a little bit painful. Very easy to make a slip up in terms of a command or something, and you can easily fix that, of course. So I think the other thing I would say is, how does WebAssembly fit into the overall development process? What is the mechanism that we use to integrate this into how we build other software? That is something that I think hasn't been given a lot of thought, or at least I haven't come across very much in that space. So I would say that's another thing to think about. Beyond that, I think once you've used it a little bit, and once you're accustomed to the kind of the workflow as to how you get things done, as I mentioned in the presentation, the installation of the SDK and the toolchain is a one-time operation. You don't need to do that repeatedly. But the thing is, the actually building the code locally, yes, I mean, it takes a couple of minutes of effort, and then obviously there is the code itself that you want to use. How do you go about testing this? What happens if there's a mismatch between the width and the actual WASM? What happens if there is a bug? How do you debug this? Once you've uploaded into the database management system and you're seeing some problems there, how do you isolate the problem and how do you fix it? Those are things that I think we need to think about more. So certainly there are issues around this. It's by no means perfect, but I think the benefits are good. It gives you a lot of opportunity to utilize code that you may have built previously. So there's great potential for reuse, okay, potentially. But at the same time, I think these couple of points that I've mentioned are things that we need to watch. They are, points to consider and beware of. Not everything is great. I mean, that tends to be the case with all new technologies. I mean, we tend to look for the great and the rosy side of things. Sometimes we forget that, there may be limitations and problems and issues that we haven't thought about. And I think certainly with WebAssembly, I was asked this question one time, someone interested in how to incorporate this into a standard development workflow, and I didn't have a great answer for him. And I still don't have a great answer for this, even though I've researched it a little bit. So a few things I think to think about there.
Yeah, as usual, but if the pros outweighed the cons, and it looked like, at least what I understood from your talk, so I think still great product, and yeah, nothing is without flaws. And all right, last question, since we have only 2 minutes left. Is WASM implemented in cloud providers like AWS and GCP?
Oh, great question. I'm not aware of it at the moment, but potentially there's nothing preventing that from running. The environment that I used today was very much a local install within a virtual machine. However, I could equally upload my WASM into a cloud-based database as a service, and it would happily run there. The reason I didn't do it is simply for caution, in the sense that as reliable as the internet is, and I have a fairly reliable internet connection, sometimes, Murphy's Law, anything that can go wrong will go wrong. So having a local environment that I can show you is a lot easier. Again, for the Bytecode Alliance, if I just switch to that page for just a moment and have a look, well, I can see that Amazon is a member. Cisco, let me have a look. Microsoft, these well-known names are members of this alliance. So I don't think, conceivably one can see that having this ability to execute WASM in the cloud provided by these major vendors, I don't see a particular problem or limitation. I guess there would be some issues around security, those kind of things. Again, just making sure that privileges, and those things which are important. You want to be sure that if it's working with, say, sensitive code, that only the people authorized to run the code will do so. But again, within a DBMS, I mean, we can do grant and revoke in terms of permissions. So that's not a problem there either. Again, I don't see any issues as to why it couldn't be run by these cloud providers, but again, I haven't come across any examples. Generally, a lot of the implementations are done by the smaller vendors. So, the likes of ScalarDB, for example, and there are others. There's a wonderful article just published recently, and Benny, I'll share the link with you afterwards. I don't have it to hand, but it's a great read on WASM because it shows that, for example, SQLite, someone has done an implementation for that. And there are a few others as well. So it shows that there are people working on this and doing these implementations, but generally it seems to be that it's much more the smaller companies and the smaller vendors at an accelerated pace rather than the big cloud providers right now. That's my kind of impression.
All right. Yeah, you can, of course, share every link you have with us. We can also implement it in our recap newsletter that goes out on Friday. So we are thankful for every resource you can provide for the community.
I'll do that, yes.
Yeah. Akmal, thank you so much for the awesome talk and for the particular interesting Q&A also. Wish you a nice rest of the day and hopefully see you soon.
Thank you very much, Benny, and thank you to the organizers, and thank you to my fellow speakers, and thank you to the audience. And everyone, have a great conference, have a great track, and enjoy the rest of your day. Hopefully, I may get to attend the conference itself, so I may get to meet you if you're there. So.
Hopefully. Looking very much forward to it, Akmal.
Thank you very much.
Bye.
Thank you. Bye.
Right, and before we go on to the next speaker of the day, just 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to machine learning and the next speaker of today. He is head of infrastructure at VoiceFlow, has over 7 years of experience in tech, is the organizer of the DevOps Day and the Spanish Alexa community, and he even wrote his own book, The Alexa Revolution. Welcome, Javier.
Hello.
Hello. Thank you so much for joining. How are you?
Doing well. Here in Madrid, nice day, nice weather.
We have said also sunny today in Vienna, but maybe 10 degrees less than you in Madrid. Javier, before we start, would you mind sharing with us real quick what we're going to learn from you today?
Yeah, so as you mentioned, I've started like setting my knowledge in terms of conversational AI specifically in Alexa technologies, with voice interaction. But today what we are gonna see is basically how to integrate Dialogflow CX and how to use and like an introduction to Dialogflow CX, so all the people can start building assistants, chatbots, and also with all these chat GPT, all the things that are appearing right now, how to embed or how to use all these generative AI technologies in the Dialogflow CX.
All right, then Javier, I would say without further ado, stage is all yours.
Perfect. Is my my slides are live? There we go. Perfect. So yeah, welcome to my talk. So today, as I said, we are gonna like understand and learn how to create assistants using Dialogflow CX, and then I'm gonna explain how to integrate ChatGPT, or in this case, as we are gonna talk about Google technologies, I'm gonna explain how to integrate Palm API or generative AI under Google Vertex on Google Cloud, which is the Google Cloud solution of Palm. Okay, so yeah, let me introduce myself first. So I am, like as he said, I'm organizer of the Alexa community in Spain, also Madrid DevOps and the conference DevOps Days, but also co-organizer of the Google Developers Group here in Madrid. You can find all my content in basically in GitHub, YouTube. I usually do like monthly Twitch streams at Shabidop. I have the same tag everywhere. And you can find my resources at shabidop.me. Okay, that's my blog where I usually share articles in Spanish, but also in English. Okay, so yeah, no matter where you are, you will understand my content. I'm working as a head of infra at VoiceFlow. VoiceFlow is a company that it's a web application that allows you to create assistants as well, but in this case, it's a no-code tool with drag and drop boxes that you can link and make your conversation as a flow and create assistants in less than 5 minutes. One of the recognitions on the Google side is I am a Google Dev Library author and contributor in the machine learning and Google Assistant things, and then I was recognized from Google as a Google Cloud Champion Innovator. That is like the Google Developer Expert, but from the Google Cloud side, okay, in the machine learning category. I have other recognitions like GitHub Star, Alexa Champion, AWS Community Builder, Microsoft Azure Content, and then Advocate of AUS Zero, and also Ambassador Labs Advocate. But today we're gonna talk, as I said, about Dialogflow CX. So what is Dialogflow CX? Dialogflow CX is basically the conversational AI platform that provides a new way for designing agents or assistants, taking a state machine approach to agent designs. Okay, so basically it's a kind of similar to VoiceFlow, but from Google. So basically, what you are gonna create is assistant by creating boxes as well. That on Dialogflow CX is called pages, and then you are gonna transition from one page to another. Okay. And depending on the, like on what the user said, depending on events, depending on whatever you want, you are gonna transition from one place to another. So that's why you are gonna have this state machine approach. Okay, this is super important because when in the past, when you were developing like chatbots or assistants overall, one of the most complex things is to manage the conversation itself, the state of the conversation. Let's say that I am a user and I'm requesting thing to the chatbot. So me as a chatbot, from the other side, I have to know who is this user, in which part of the conversation he or she is right now, and what is the next step. Okay. In the past, without this kind of state machines approach, that's something that you have to develop on your own, or using some hacky solutions and creating a bunch of code, which now with Dialogflow CX we will see. I'm gonna give you a demo, but we'll see that it's super easy to create assistance and transition from one place to another. This is basically how, this is from the documentation, but basically this is how Dialogflow CX works. So in this case is the edit order flows. Another important things, I mentioned that Dialogflow CX has pages, which are the boxes, that you can go from one page, from one box to another page, to another box. But on top of everything, you have flows. Okay, so you can have like a better like a structure, from for your conversation in terms of flows. What does this mean? So what it means is basically that when you are like creating, for instance, an assistant for a bank. In a bank, you can do a bunch of things like I don't know, like check the balance, make a transfer, chat with a human. So these kind of things are different flows. Let's say that the assistant is about your bank, like bank assistant, but in the end, what you are gonna have is different features, different functionalities. Okay, so that is gonna be in a flow. Okay, so the bank transfer is gonna be a flow. The check your balance is gonna be another flow. So what you are gonna have on each flow are these flows itself, these pages. Okay, and you can transition to a page or to a flow. Okay, that this is also useful because you can create a reusable flows. For instance, for the bank assistant, you can create a flow just for the payment. Let's say that you are gonna connect with Stripe or with PayPal, and you want to reuse that flow. So in this page, for instance, let's say that you are in the confirmation, you can transition to that flow, go to the payment flow, and then go back. Okay, instead of on each flow creating a bunch of pages just to work with the payment process. Okay, so basically these are the two most important concepts in Dialogflow CX, which is flows, which is the highest top level. We will see it in action, and then pages. Okay, which are the states itself, the small states within a flow. So Dialogflow CX has machine learning inside. It is powered by machine learning, and the machine learning that it has is the natural language understanding. Natural language understanding is a subtype of the natural language processing, and basically what it does is it gives you, depending on the rules that you have specified, what our users are trying to tell us. Okay, for instance, that if I wanna check the balance of my account, the natural language understanding is gonna tell us that the user is requesting for the balance, and not for the balance of, like someone. Is the balance of this specific user. So for example, if we check this another example, which is tell me the weather of Madrid, what we are gonna see is that tell me the weather of Madrid is an utterance. Okay, we can request or we can ask for the weather of Madrid in multiple ways, like tell me the weather of Madrid, how's the weather in Madrid. There are different ways of requesting information. Those different utterances are requesting the same thing, okay, the same intent. So multiple utterances are gonna match one intent, okay? And then Madrid is the parameter, because could be Madrid, could be Vienna, could be Valencia, could be whatever, okay? Those parameters then are entity types that are defined, okay? So what you are gonna define basically under your NLU is all the intents, for instance, get underscore weather, and all the utterances, okay? Like tell me the weather, the ones I told you. And then on the other side, you are gonna create an entity type called city, and you are gonna add all the cities, okay? Of course, there are built-in entity types. So for example, the city one is, you don't have to create an entity type with all the cities of the world, okay? That is already there, and you can use it. So that is basically how the natural language understanding, the classic natural language understanding works, and how this works on Dialogflow CX. So whenever we request, let's say, like in this case, we have the a chatbot that tells you the weather, you will need to specify this get weather intent, and then the entity type, okay? So in a super easy way, you will see you will track that on the flows and on the pages. And for instance, you can trigger, or you can transition when this utterance is executed, is triggered, you can transition to the get weather state. So you can call your webhook, etc., for example, just thinking in the Dialogflow CX manner of doing things. In terms of designing the NLU, that is the process that we should follow. What we have is basically the design. So it's on the design side, how we are going to interact with our chatbots or with our assistants, okay? Because with Dialogflow CX supports a bunch of platforms. We will see it in a bit. But basically, it's first design how to interact with it, okay? Then build. That means that add all these utterances, add all these entity types, etc., and then train. Okay, when we train is when we are gonna give all the utterances, all the entity types to the machine learning model, and then if the Dialogflow CX, it is gonna start understanding us. Okay, if we don't click on train, it's like we have the data there, but we don't send the data to to fine tune the model or to train the model again. Okay, and then evaluate. That means test, and test. Okay, check that everything is working fine, and check that everything is working as expected. So how it works, the Dialogflow CX. This is another image, another picture from the CX documentation. But basically, if we go from here, okay, let's follow the numbers, okay, the ordering here. So basically, we are an end user, okay, that is gonna interact with the CX assistant. On Dialogflow CX, you will find a CX assistant or CX agent. Okay, the official name is agent, but I don't like that too much, so that's why I said assistant, because at least for me it's more natural. But when you go to the Dialogflow CX, you will see agent. Okay, but yeah. So going back here, the user interacts somehow. That means by phone. That means by typing, or by like handwriting, or just by audio with a client application. Okay, that client application could be WhatsApp, just the phone, Telegram, Facebook Messenger, Instagram Messenger, etc. So when the user says, for instance, send me the weather of Madrid, it will interact with the client application and it will call the Dialogflow CX API. Okay, there's one API that we need to trigger to tell to Dialogflow CX, okay, I am the user with this user ID, and I am requesting this. Okay, so Dialogflow CX internally, when you call to that API, what it is gonna trigger is, okay, you are this user in these flows and pages in this state machine. You are in this part of the conversation. You told me this, so you have to transition to XYZ flow or page, and these things are the things that are going to be executed. For instance, requesting a webhook service that can get information from the database, or requesting external APIs, for instance, a weather API, for example. So when that happens, we have a response. The service Dialogflow CX, like the state machine, is updated and it will give us the response. Okay, the response is basically all the messages that we need to send to the user, okay, in an array. And then on our app, for instance, if it is WhatsApp, what we are gonna see is basically the reply. Okay, you have the request and then we will have the reply. Okay, and then this output is the thing that the user is gonna see. Okay, this is how Dialogflow CX works. There are built-in integrations and there are custom integrations. Okay, we are gonna see it in a bit. So for the webhooks, the Dialogflow CX accepts a webhook. So in any time during the conversation, you can call a webhook. The architecture recommended for developing the backend on Dialogflow CX is basically a serverless. That means that, and we are under the Google and Google Cloud ecosystem, the technology recommended is Google Cloud Functions, okay, which is the Google Cloud serverless service. So what you are gonna deploy there is just functions. And why serverless? Because, for instance, not all the people is interacting with your chatbot at the same time. You know, like I don't know, like these interactions are like spontaneous. You know, so that's why I usually prefer a serverless architecture. Of course, if you have a bunch of interactions, we should reconsider that to deploy the webhook as a server. Okay, that is also available. Another technology recommended is the cloud storage, Google Cloud Storage, GS, the GS buckets, basically. So where there you can push your assets like audio, media, like video and images. So you can push there and you can retrieve it in a super easy way. And to check what is going on your assistant, you have Google Cloud Logs. Okay, so for the assistant itself and also for your cloud functions, you can check the logs there. And for database, there are some built-in small databases per assistant on Dialogflow CX. But if you want a persistent database, the recommended is Firebase Firestore, okay, which is the NoSQL Google Cloud solution as a database. Okay, yeah, I recommend NoSQL because it's the fastest, the more dynamic, and the easier to use. Okay, in terms of client SDKs, for the Dialogflow CX API, so Dialogflow CX has an API to manage your assistants. Okay, like for instance, creating intents, creating utterances, creating entity types. There is an API And it has a SDK available in JavaScript, TypeScript, Python, Golang, Java, C++, and C#. Okay, this is basically to manage your assistant without the UI. Okay, and yeah, and how to build this, basically like this Dialogflow CX and the assistant itself. So my recommendation is to see like to have an idea, to start from a starting point, then go into the like to the design phase, as I said before, like design how your assistant is gonna looks like, then develop the backend, develop all the webhooks, all those functions, develop whatever you need, unify all the NLU plus the backend. Okay, so all your designs, the NLU, your basically the interaction with the backend, and then test. Okay, we can add afterwards some branding and then deploy to production. Okay, on Dialogflow CX you can create environments and you can create versions, and you can promote those versions to each environment, for example, which makes this really easy to test. How to test your assistant agent on Dialogflow CX. So there are multiple options, quite powerful. The first one, this is before we go to the test itself and how to test your assistant, let me explain you the Dialogflow CX console. So this is the Dialogflow CX console. Here is the flow. Okay, this is the default start flow, and these all boxes that you are seeing here, these are pages. Okay, so if we want to create a flow, we just click on here on the plus button and we will create a new flow, and that flow is going to be empty. It's just going to have like the start page like this one in that flow, and then from here we can transition to another flow in a really easy way. In terms of testing, in the Dialogflow CX console, we have the test agent. Okay, so when you click there, you select the version that you want to test and the environment that you want to test, and then it's as easy as this. You can start testing your assistant here just by typing. Okay, you can use your voice as well, but it's as easy as that. Okay. Then there are some automated tests. So whenever you create or whenever you have an interaction, that interaction, you can save it as a test. Okay, those tests can be added to a CI/CD environment. Okay, so whenever you create a new version, or whenever you publish a new version to a new environment, all these tests are gonna be executed automatically. Okay, so in super easy way, you will make sure that all the changes, or at least the happy path, are gonna be running and are not gonna be broken. Okay. Integrations, as I said, it has some built-in integrations. The first one is the CX phone gateway, which is basically just like an IVR, interactive voice response. What is an IVR? Are those systems that are telling you press 1 to whatever, press 2 to whatever. That is like some automated thing. So that is something that you can build and you can use, and it's the built-in integration there. And then there are some other telephony integrations like Avaya, Box Implant, Audio Codes, and Twilio that you can use. And in terms of text-based, it has the Dialogflow Messenger one, which is basically the classic bubble that you have that you can put on your website, and it goes like it shows up when you open the website. So that is the Dialogflow Messenger integration. And then the Facebook Messenger, that means that you are going to create your app on developer.facebook.com, and you are going to fill here all the things required, and that's it. Like the app ID, all these things, and that's it. You don't have to build anything or to deploy anything anywhere. It's just built in, like plug and play. And same for Line. For custom, for instance, like Telegram or WhatsApp, there are not direct integration. Okay, so what we have to build is basically in just a super, I mean, the code should be like less than 100 lines, but basically we have to deploy some man in the middle. Okay, so it is a server or a serverless that gets the input, for instance, from Telegram, calls a Dialogflow CX, get the information from the Dialogflow CX, transforms that information in a Telegram way, and it shows you and it sends that information to Telegram, to the user. Okay, these are the steps that I'm explaining here, but it's basically get the request from Telegram, extract the text from Telegram, make the request to Dialogflow CX, which is the detect intent request. Okay, get the request from Dialogflow CX, parse that Dialogflow CX response, and then send the response to the user in a Telegram format. Okay, basically a man in the middle that transforms from one thing to another. It's super easy. Like you usually are gonna do that in less than 100 lines and in less than 30 minutes. Okay, so you can deploy this and having chatbots in whatever platform you want. Demo. Let me show you here. So this is the example that I showed you in the other slide. Basically, here are the flows. So when I click, for instance, in this start page, what we are gonna see are the routes. Okay, the routes are the transitions that I told you. So for instance, the product info, that is when we start the interaction with these assistants, when an intent, remember the NLU that we talked about? When an intent is triggered, this intent, the product info, we are gonna transition. Okay, when we are gonna transition to the page search information form. Okay, so how can we trigger this intent, this product.info? That is here in the entity types, no, intents. Here we have product info. So here is where we are gonna see all the utterances, which are training phrases, right? So tell me about OC. Hello, please find me operator guide for ICI. What is what is deployment info for OH? Okay, so if you can see here, like you are seeing things in blue, green, and orange. These things are the parameters. Okay, if we go back to our slide deck, it's basically this. This is our parameters that are entity types. Okay, and the other things are utterances and training phrases. Okay, so this is a parameter, and all of these are training phrases. And then each parameter, the color, determines the entity type that it belongs to. Okay, so what that means is that what you are gonna have is under the entity types, you are gonna have all these type of entities: installation, synonyms, install process, installation. Because for Madrid, the city is just the city, but for deployment, for integration, you can specify like this thing that is variable. That could change in multiple ways. Like integrating, integration. You can say the info type in multiple ways. So yeah, for testing, for example, here you can have like as easy as this. We can interact with your assistant, and we will see a walkthrough, and it will tell you which pages and steps are being executed. Okay. So yeah, that's pretty much it in terms of the Dialogflow. Is super easy. I mean, I encourage you to create these assistants, because yeah, it's very powerful, and it abstracts you from the conversational AI side, that you just need to focus on the design of your conversation, just focus on your on your final product instead of dealing with code and all these things. That is everything is managed by Dialogflow CX. Okay, so go there and check it out. Yeah. Let's continue with the presentation. So Dialogflow CX CLI. So what is this CLI? This CLI is basically a tool that is developed by me, and yeah, me as a developer. It is also there are some Googlers contributing to it. So basically, it's a tool that helps Dialogflow CX users to test their projects and interact with them in multiple ways. Okay. Basically, with the Dialogflow CX CLI, what you can do is basically CRUD operations like create, read, update, and delete CX resources like intents, like flows, pages, entities, a bunch of things. And there are some testing capabilities which are very useful. For instance, you can trigger a CI/CD pipeline. You can have an NLU profiler. I will explain you what is the NLU profiler. And you can interactively test your agents just from the terminal, okay, which is really, really cool as well. It has a speech to text and text to speech capabilities. That means that with this CLI, you can transform text into audio in just one CLI command. Using the machine learning services from Google Cloud, the speech to text and the text to speech. And for the speech to text is basically the same. It's just one CLI command. You can recognize the like into like an audio and transform that into text. Okay. You can find the documentation in Dialogflow CX, under my GitHub, Dialogflow -cx-cli or the cxcli.shabby.me. Okay. And yeah, that's pretty much it. I forgot to mention, I told you that I'm gonna explain what is the NLU profiler. So let's explain the NLU profiler. The NLU profiler, what is basically it checks that let me open the documentation, so that is gonna be easier for you to understand. We go here, that is under agent, no, environment, entity types, here, NLU profiler, sorry. Let me show you this example. This is a simple example. So basically, what the CXCLI, what it is gonna execute is a suite, and that suite, which is a YAML file, it is gonna has like multiple tests. Okay. In each test, what we are gonna test is basically like an input, and then the expected things that should be triggered. Okay, for instance, it's basically to check that if we are gonna the input, the type is text, because as an input we accept audio as well, so it automatically is gonna have the speech recognition, transform that into text, and send and use that text as an input. But it is gonna validate that the intent that is gonna trigger is a high intent. Okay, and if we type hello, the intent that is gonna be triggered is the high intent as well. Okay, if we check a text like a more complex one, sorry, example, for instance, here the input is I want 3 pizzas, and then we are gonna validate that the intent that is gonna be triggered is the order intent, and then the parameters that are gonna be there or that should be there is a number with the value 3 and order type with the value pizza. So with that, what we are gonna ensure is that our NLU first is working fine, and then during all the change and after some time that we execute this, and after some changes, our NLU has the same like specification. Basically, for the audio is like this. Instead of using type audio, you have to use type instead of using type text, you have to use type audio. and then you specify the MP3 file, okay? And it will do, as I said, automatically using machine learning, the speech to text recognition, and then sending that to the Dialogflow CX NLU, okay? So we're gonna use two machine learning process, basically the speech to text and then the NLU. And yeah, that's pretty much it. In terms of the generative AI and how to integrate all these things for in the Dialogflow CX. So my suggestion, let me here. It is gonna be like something or how to create this like in an easy way. For instance, here let's say that this intent is gonna be triggered, okay, and or this is the default welcome intent, okay. So here, instead of adding the agent says, okay, what we can do is under the webhook settings, we can create a global webhook settings. We can deploy a global webhook that what it does is basically the input that is gonna have is a prompt, okay, and then that webhook is the one that is gonna interact with Palm, for example, using the Palm API or using the Vertex Generative AI Studio with Bison, or all the fine-tuned models that you can create on Google Cloud Console. Okay, the large language models you can fine-tune right now on Google Cloud. I am playing with it and it's pretty cool. So in that case, what you can do is you can like set a parameter, okay, like for instance, let's say assistant, okay, dot prompt, and then here you can say, instead of value, what you can add is say hello to the user, specifying or welcoming to WeAreDevelopers Machine Learning Day Conf. Okay, so then it's as easy as then on your webhook, what you are gonna have is basically enabling your webhook. You will create a webhook, and that webhook you are gonna specify that parameter. Okay, that you are gonna send that parameter, and then that webhook is the one that is going to interact with or Palm API or OpenAI, or with under Vertex, under Google Cloud, with your fine-tuned LLM, or with your with your LLM, in general, to, instead of having, because here, as you are seeing, is like the agent says is basically like a random, like you provide three options, and then randomly the Dialogflow CX, it is gonna give you these three. But for instance, if you're interacting with this chatbot like a bunch of times, these three are not gonna be enough. So it is better to have like these kind of interactions, like to using generative AI to have at the end better experiences, from the end user's perspective. So yeah, it's as easy as this. The webhook that you can create is basically should be generic, and yeah, that's pretty much it. Sorry. So yeah, again, thanks for being there and for attending my talk. Thanks for WeAreDevelopers to having me here. And yeah, you can find all my content in shabidop.me. Thank you very much.
Hello again, Xavier. Thank you so much for the awesome talk. And as we have some minutes left, I would say we jump into a quick Q&A, if that works for you. And to kick it off, I would be very interested in also your developer journey. Like, how did you become interested in tech, and what was your journey to the point where you are now?
Yeah, so my journey, I think that is kind of different because, well, I've started like as a regular Java developer here in Spain. Then I was like moving to test automations and then just automations. And since 3 years ago, I am doing like a bunch of things here at VoiceFlow, like platform engineering, like developing tools to make their life easier and automating things, CI/CD, infrastructure as code, and cloud in general. And then, which I love, like working, doing that is something that I love. And then there's another thing which is my hobby, which is assistance and how to interact with computers, basically using human language. So that is where all the conversational AI thing with Alexa, with Dialogflow CX games, right?
Right, yeah, thank you for giving us insights in that. Let's move on to some more talk-related questions. First one would be, what are the advantages of Dialogflow CX for similar products like Azure, AWS, etc.?
So basically, it's by far one of the easiest platforms to start and to develop conversations. Okay, and the focus, or the main focus here, is basically on the conversation. So you can forget about like coding and all these things. It's just a matter of like creating the conversation. So, and if you wanna like even a more easier platform, that is VoiceFlow. So my recommendation is gonna be use VoiceFlow to design your conversation, and then once you wanna like deploy that conversation in a real world, go to Dialogflow CX for sure.
All right, thanks. Next question. What about security and privacy considerations when using Dataflow CX for bot development?
So yeah, that is a great question. Everything that you develop and deploy on Dialogflow CX is under your Google Cloud project and under your Google Cloud account. So everything is secure, and Google Cloud has like basically all the security standards and compliances, like ISO, HIPAA, PII. So it is a safe place. Also for instead of using the public Palm API, if you are using the like an Palm deploy on your Google Cloud platform using Vertex, or a Palm fine-tune using Vertex on your Google Cloud, that is going to be only on your Google Cloud account and your Google Cloud project, basically. So it is a safe place to deploy your things.
All right, thanks for clarifying that. Next question. Does Dialogflow CX handle multilingual bots and support different languages?
Yes, you can add more languages and create like different interactions per language. I would say as a recommendation that if per language the interaction is way different, because like people from other languages interact in different ways. If the interaction is way different, I would recommend to create one, let's say, for English and another one for Spanish, for example. One agent for each language, basically.
All right, thanks for that. Next question. Are there already some successful real-world use cases with creating bots with Dialogflow CX you could mention?
I'm not sure. I know like a bunch of companies are using it for internal purposes. And it's like a platform that is widely used for big corporations. But I cannot tell you specifically like this one was built with Dialogflow CX, but I can tell you that there are like a lot of big companies that they are using Dialogflow CX as a assistant tool, as a chatbot tool.
All right, thanks. Next question. What advice or suggestion do you have for developers who are transitioning from the previous version of Dialogflow to Dialogflow CX?
So yeah, that's a great question. So Dialogflow ES, which is the older version, they have to develop a bunch of coding. So I think I didn't have too much experience on ES, but like they have, I think it's something called context or something like that, and there's not like a graphic view of your conversation. Like it's way complex to create conversations there. Just to use the NLU is super easy, but if you want to create a conversation using ES, is more complex. So my recommendation is gonna be like basically there is one official GitHub project from Google that like migrates from ES to CX, but I heard that there are some issues with the tool. But like just try it and see if that works. But if not, my suggestion is gonna be export the NLU and create the NLU on CX, and then recreate the conversation on CX reusing the webhooks, reusing the code basically that you have.
All right, thank you so much. Next question. What are some practical applications or scenarios where Dialog CX bots can be effectively utilized?
So any kind of, for instance, that you have a business and you wanna like create an FAQ bot, for example, that Dialogflow CX helps you a lot. Like any kind of business interaction, like I don't know, to book some like a table in a restaurant, to book flights, these kind of things. If the conversational is well designed, then it is gonna be really nice to use Dialogflow CX for that use case.
Right, yeah, nice example. Thank you for that. And another question. Does Dialogflow CX offer integration capabilities with various platforms, systems, or external APIs, such as CRM systems?
Yeah, like there's an endpoint. The one that I mentioned in the presentation called is the detect intent, that is under the session per user in the Dialogflow CX API, in that chain of the API. So yeah, basically you can create and you can like build custom integrations for the Dialogflow CX and embed that in a CRM, embed that in your like your custom app. Like I don't know, if for instance if you wanna use it in your Flutter app, it's as easy as create that integration, which is super easy.
But thanks for this as well. Kavi, you wrote a book, The Alexa Revolution. Maybe you can give us some insights, maybe cover some of the topics that you are discussing in this book, and maybe also what was the writing process? How do you write a book about Alexa?
Yeah, so basically the book itself is about like it is like a from zero to hero book. So it starts with like understanding what is Alexa, what is an Alexa skill, which are the applications that you can build for these devices, and it explains you like the whole ecosystem, like how to all the things related to the NLU, all the like specific features, how to build a lambda, how to deploy a skill, how to publish in the SingleStore, and yeah, so and it has like in every chapter you have to build a new like a new part of that Alexa skill. Like it's just super easy, and it comes with a GitHub repo, so everything is aligned, like a chapter with the GitHub repo, and everything is incremental. And yeah, like how to think or how to write a book is basically what I did is create like like the index, like the chapters that I wanna talk, and then once you have that, for me at least was the hardest part, is just start writing. For instance, if we were creating a Dialogflow CX book, we can add as an index, like introduction, I don't know, like NLU, agents, flows, like you can start writing those chapters, and then it's something like it is not easy, like it requires time, dedication, and also to be consistent, but like once you have the index done, like the ideas are just coming and you just need to write them.
So the tough part is, as so often, beginning to begin.
Exactly.
From what you told me, yeah, I know this. All right. You are also organizing a DevOps Day and a community in Madrid. Maybe you want to also share some like tips or insights on how to manage communities.
Yeah, so yeah, I am, as I say, I'm organizing like Madrid DevOps, and then its big conference at the end of the year, which is DevOps Days Madrid, GDG Madrid, the Google Developer Group, and also the Alexa one. And yeah, basically, the community of developers is a community that you wanna create or that you wanna organize. That could be, I don't know, like for instance, WeAreDevelopers is like a broader community that like has, I don't know, like backend, ML, whatever. You can create a community in about the topics that you want. If you want to create a community of a specific technology, you can create that as well. But basically, in terms of tips, is right now I would say that a lot of people is or wanted to start going to in-person events again. So I would say to start doing some small in-person events, get a venue around your place, around the city that you are gonna host those meetups, and be consistent, like trying to create one event per month, trying to create a sponsorship with local companies, with big companies as well. If you are gonna talk about Google, so let's talk, let's ping Google and say, okay, how we are gonna do this event? Can you sponsor me, like I don't know, for paying catering or for bringing like top speakers, for example? So yeah, but and also not another recommendation, which is I think important, is not to be alone. Like at least start a community with 2-3 people, so you can like each of you can focus on one thing, and you are not alone, doing all the stuff basically.
Yeah. Sharing the work always works, and making a habit of it. That's always, as it is with so many other things, it's the way to go. All right. We got some more questions also from the community. What are the limitations of building bots with Dialogflow CX?
I think the limit is most in your head, like you can build whatever you want, and yeah, like I didn't have any limitation. I mean, I'm pretty sure that when you start developing things, probably you will find some limitations, but overall, like it allows you to create a bunch of things.
All right, so also like technical limitations, there aren't really any. It's really just what you make out of the resource.
Yeah, I heard that for the telephony integrations, like there are some issues, trying to integrate with it, but overall it's fine.
All right, happy to hear that. Next question. How would you try to start implement automations and bots in a company? How would you convince your CTO or CEO of using automation?
So basically with data, like that means that let's say that with creating a chatbot or creating a bot or an assistant gives you like more time to work on other things. For instance, for the customer support, let's say, if there are a lot of people, if there are a lot of if the customer success team is spending a bunch of time resolving or answering the same questions all the time, then you can create a chatbot for that. Same internally, like if you have I don't know, like you want to make a request, I don't know, to give you access to this system that can be implemented in the chatbot, in a chatbot, so the I don't know, like the sysadmin team can be focused on develop new stuff, instead of interacting with these end user requests basically all the time.
And as so often you can write whatever you want in your FAQs. Most of the time people will nevertheless write an email before they take a look at those. So yeah, could be a very useful use case, of course. And as a closing question, good closing question, I think, where do you learn all of this? Any resources to share?
Just reading the documentation, the Google Cloud documentation, GitHub, like seeing other examples, seeing like other people in the community, like going to the Google Cloud Slack, to the Google Cloud Discord, and seeing what the other people is building. That is quite interesting and a good starting point. And also like all the content that I'm creating on YouTube, on articles, that is also good, so you can learn from my experience as well. On YouTube there are another YouTube videos. There's not too much, but there are things.
All right, to get a hold of the basics, and rest is research or do it by yourself.
Exactly.
Okay, thank you so much for the awesome talk and also for the Q&A. Hope to see you soon on another live day of ours, and until then, stay tuned and have a nice day.
See you. Thank you. Bye. Have a great
See
day.
ya. Bye. So, and before we jump to the next speaker of the day, 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to the next speaker of the day. She's senior product manager at TELUS, has 7 years of experience in statistics and machine learning. She built an internal product for Google Cloud and also has experience in startups in the retail and healthcare domains. Welcome, Julian.
Hey, everyone. Thank you so
Hello.
much, Benedict, for that introduction.
Nice to have you. My pleasure. I've already seen that you shared your slides with us. So to the audience, you can click them in the chat. We will post them for you, so you can go through besides the talk. And talking about your speech, maybe you want to give us some insights in what we're going to learn from you today.
Sure. Today we'll be covering one of the very commonly used retail machine learning. It is, though it might sound like an advanced theory concept, I would love everyone to go back with an understanding of what is happening, and also recognize the different machine learning trends that are happening in and around us. I'll be giving you the behind the scenes sneak peek on, what's happening when you are actually on social media, what's happening when you are shopping, and stuff like that. Hope you enjoy.
We will. And so I would say, without further ado, stage is all yours.
Absolutely. I tried not to give away a lot of suspense on that. So I love this quote on data, that it is something that helps us enhance our intuition. A lot of you might have seen a lot of these different changes, and we'll go in detail about what it is. And just like Benedict introduced me, I've been working as a developer and now a product manager in the tech industry for the past 7 years. These are the companies that I've worked for, and I love being a part of these communities and speaking at events and making friends, new friends who are all like-minded. So I've also been an ambassador for women in data science for the past 5 to 6 years. I'm right now in Vancouver. I just immigrated a few months ago, and I'm part of a WITS Vancouver as well. So would love to get to know some of you right after this. So feel free to get in touch. I'll be sharing my socials by the end of the talk. Without any further ado, we have this as the agenda for today. We'll go through a bunch of real-world machine learning applications. A few of them that I'm going to be talking we're going to be focusing mainly in the retail industry, the e-commerce industry, because most of us do shopping online, so we'll focus on e-commerce as well. And what's mostly important by the end of this is the understanding and the interpretation of these results that the ML models come up with, because nowadays all of you know how generative AI is building models and spinning models left, right, and center. You should be the ones who know how to interpret them. I'll also have a touch base on the different best practices you can implement when you are running a team, leading a team, or even as a junior developer. You need to know these different best practices that exist when you try to ship your products to a large scale. So we'll definitely go through that and a few roles within the data science industry. If you have access to chat, I would love to see. I can't see them right now, but do let me know by the end as well when we start interacting whether or not you've seen these images. So the first one is from Amazon. If I hope this is really clear, you can see the image. That is the customers who bought this book. Let's say it's a book on Fahrenheit. They have also bought another book. I'm sure you've seen this coming up, not just in Amazon, H&M, or any other website that you use for shopping on a daily basis. By the end of, or let's say you're watching Netflix, you've just finished watching Emily in Paris, you would have just like that, or if you're on Amazon Prime, or if you're on Netflix or any other HBO that you're streaming application that you would be watching. Once you finish seeing something, you will have suggestions or recommendations for what to see next or what to buy next. I hope you've seen this. Try to think about what kind of data did they actually use to bring that kind of suggestion up on your screen. Think about that for a second. Now, the image that you see is Instagram. Here, like if you're nerds like me, you would want to be not controlled a lot by the algorithms because once you understand what's happening behind the scenes, you would want to click on those suggested posts or ads that come up in Instagram in between when you're scrolling in your free time. You're like, why am I seeing this ad? And if you've ever clicked on those 3 dots to say hide ad or do not see suggested post for the next 30 days, snooze suggestions or recommendations, you would have gone and clicked on that. Do you know how does Instagram come up with those recommendations or those suggestions or ads? And do you think your friend who is maybe scrolling right next to you at this moment during the conference is seeing the exact same ones? Or is he seeing is he or she or they seeing a different ad altogether? So that's what happens with Google Ads. If you even search for something based on who you are, where you are in this world, you might end up seeing a very different ad. and companies actually bid for that ad space. That's how 80% of Google's revenue is made. I think it's quite a lot of everybody knows that. But these are the different big tech companies, and I think all of you might have seen these. Feel free to think about this. And now we'll try to understand what's happening behind this, and we'll come back to what actually causes each of them. So I would like to introduce you to a very small data set, which is not what you will be looking at if you're working as a data scientist in a big company. This is a 4 KB data set, very small. You'll have petabytes of data set to work with in the real world. And this is just to introduce you to a very small concept here. So here we have taken mall customers.csv. You can see it on your screen. I took it from Kaggle. Kaggle and GitHub should be your best friends by now, since you're all interested in machine learning. Now, this data set has 5 columns, as you can see: customer ID, the genre, gender, age, annual income, and spending score. So these are the 5 different things. Now, just by looking at a tabular data set, you can't really make a lot of sense out of it. But maybe you've joined a team. Let's say you are working as a data scientist at H&M, or any like, think of your favorite brand of shopping right now. I just know H&M or Aritzia here in Vancouver, but think of anything that you are happy to imagine right now. These are the different possible outcomes that your team would want you to come up with. So when I walk into a mall to shop, I might not have any label on me that says I fall under this category. But as a data scientist working for that team, every company today is a data company, and they would have these data engineers or data scientists figuring out what is the trends, or what are the different people who are interested in one item, or who have the tendency to spend more than a particular another segment of candidates who come into the mall, or who spend less than a certain bar over the past few months. You would see that a few customers always spend less than X. So these are the different outcomes or the objectives that you're looking to achieve when you've been given this kind of a data set. So what we are going to use behind this is called audience segmentation. This should have been the title of my talk, but I didn't want to give it away. But it's super common, and this is a very commonly used unsupervised machine learning algorithm. So what it helps you do is to group unlabeled data into possible similar categories, so that all of your campaigns that you would want to run can be more targeted. So you would, instead of running a very non-customized marketing campaign, these segments that come out as a result of audience segmentation will help us make more effective ads, more effective campaigns. They would be targeted. And when I think targeted is a very negative word sometimes, but it's not to it just helps you spend money where you would know that this is going to be useful for the customer. So we'll get into this. And I don't want all of you to walk away saying that machine learning is bad. Machine learning is good, because instead of seeing ads like, say, on Google that you would see that's completely unrelated to you, it's better to see things that would be useful to you. So yes, it's listening to you, but it's also going to help you with better ads. Now, before you move into anything, you would, as a data scientist, the very first way to make some sense of your data would be to do an EDA, exploratory data analysis. In this, what we have very commonly that we use is a scatter plot. You could use any plotting algorithm, any plot to actually understand what patterns lie under your data. So here I've used age and spending score, 2 of the 5 columns that we had. You can see it is trying to give me some understanding of maybe people who are 20 spend very less. They might not be earning yet. Those who are somewhere between their 40s and 50s, they seem to be earning quite a lot, and they're spending also somewhere in the middle. But 20 to 30, like the moment you start earning on your first job, you seem to be spending a lot. Yeah, we all fall into this category. Maybe you should not be spending that much. But you do know that as the moment I plotted this from a tabular format to a graph, I can already start telling you a story. So that's the power of visualizations. You could go ahead and try to plot it with annual income and age. So again, you will have a few patterns that you can see between this. There's another plot that I've shown you here for annual income versus spending score. And again, there's some kind of a story that's brewing right there. So doing this exploratory analysis will actually help you figure out which algorithm to go for, which model to go for as a data scientist in your team. Here we are focusing on clustering algorithms. Again, in clustering algorithms, there are more than one types. So you would want to, focus on which one works for you. You can't just say that just because I've studied about this, I'm going to implement each one of them. You could do that, but you would actually end up wasting a lot of your cloud resources and the time that you have been given to come up with those possible outcomes. So just a quick introduction on some of the theory behind, what if you've not seen this before. There are 4 different types. That is hierarchical clustering. This is usually used when you know that there are, what are the different kinds of, let's say you're a biologist and there are only 5 types of bacteria in this world. Or let's say there are 2 different kinds of people who attend the WeAreDevelopers conference and people who don't. So these are the different hierarchies that you can actually go through. So it is not a very practical algorithm to actually implement, because this in reality takes the complexity of writing down this algorithm. The pseudocode for all of this will be given to you when I share the slides. And all of the code that was required to print those plots is very simple. I'm not going to show you the code here, but when you write the code for hierarchical clustering algorithms, it is actually going to take n raised to 3 is the complexity. And that means the moment you go from 4 KB data set to a petabytes of data set, it's going to be super slow. So it's not practical to implement this. You would waste a lot of resources and waste a lot of time. So go ahead and do this only if you know that that is going to be suited for your data. Here, we don't know how many segments there are in our retail case right now. So hierarchical clustering would not actually suffice. Next is the distribution-based clustering. Again, this works well when you know the distribution of your data set. So the distribution of your data set can be, let's say, Gaussian, or if you know that it's going to definitely fall a different distribution based on your exploratory data analysis. Based on that, you can actually go ahead and then find out, okay, let me try to implement this based. So the more and more you work on understanding your data, the more and more clarity you will have on what clustering algorithm to go through. The next is density-based ones. Again, here, if you try to implement this, I've done this, but then what happens is that it does not really deal well with outliers. The moment you do this, you will have few clusters that come up with different shapes based on the density. But if you have a lot of different varieties of data coming into your pipeline and implement this directly without having had any analysis, you might see that the accuracy goes down, because if your data has an outlier, let's say somebody won a lottery and then shops a lot more than average, this would actually fail very bad. The one that we're going to focus on currently today is the one that is the last one, centroid-based algorithm clustering. This is super efficient, very fast, and easy to implement. So we call it also k-means clustering. And k-means clustering is basically the algorithm that we'll be using here. So here, k, the word k is the number of clusters, and you can assign it any number. But I would highly recommend not to go ahead and assign any random number. The more information you have about the domain, it would be better. Like if, let's say, if you were to apply it for the bacteria example I was saying, if you know that k is equal to 5, it would not be sensible to implement k is equal to 10 to begin with, right? So the more information you have about your domain, let's say healthcare or retail, wherever you want to implement this, the better your trial and error would begin with. So how this works is going to be mostly like this. There are 5 different steps that I've shared here. You would go ahead and say that the data that you have can be defined into, let's say, 5 clusters or 3 clusters, as you see here. Say k is equal to 3. You've randomly done this. You don't have any information. You've just set k is equal to 3 to begin with. When you do that, you would also want to initialize 3 points as the centroid. So this is a centroid-based clustering algorithm. So you would choose these random centroid points, and centroid points are just 3 different points. Like I can show it to you in the next slide. And what happens is, for every centroid point, you would calculate the Euclidean distance between that centroid and every other point. And all of those data points that actually are the closest to a centroid fall under one cluster. So we keep assigning a data point to be a part of one cluster based on their distance, and you would recompute all of the distances. You keep doing this iteratively. The moment you are able to find out, so this is the visualization for this. It'll be better if you see this. And here what happens is that you started with a lot of red data points. Like we'll wait for it to come back to this. So here is where it started with, and you see the black points here. In this black points, these black points are the centroids that you see, and we're calculating the distance between each of these data points with that centroid. And when in the very initial stage, you saw that we had randomly chosen this, and we keep iteratively figuring out what is the distance of each of these data points with that centroid. And you would find that it keeps shifting to a different cluster. So we would be able to figure out that which of these data points fall in which cluster. And that is all it helps you to do. You would want to stop iterating the moment you have figured out that the clusters are the centroids are no longer changing. So always, I highly recommend visualizing your models. The moment you do that, you'll be able to figure out, okay, this is how it's happening. Inside this as well, to be able to figure out the best number of clusters, because we've started with 3 in the first example, we can move on to 5 or 6 or 10. You would be confused, but statistics gives you a lot of different methods to actually test out the most optimal k. You can use silhouette method, you can use the elbow plot method that we're seeing here. In this, what we do is we try to find out based your clustering model is it won't be relevant if you fail to identify the correct number of clusters. So if you begin with, say, like we began with 3, some that would fall somewhere here. But we can try to keep doing this from 3, 4, 5, 6, and all the way till 10. But you would see that when k is equal to 5 is when you had the minimal drop of inertia. Like this is, you can read more about this within the slide. I've given all of the links here. But whenever the drop is the minimum, that is when we find out that the cluster inertia is the minimum. And when that happens, that is going to be your most optimal k. So considering that to be my answer, I can, if I've had a different data set, maybe k would be something else. But here in this case, k has turned out to be 5 as the most, as that point where you can, I'm not saying that data science is a science of trial and error. You can always go ahead and try out it to be 3 or 10 or anything, and then see that how the accuracy of your objectives actually change or not. Given that I've taken k is equal to 5, I ran the k-means algorithm, and I got this particular column being added for every single row. So this is how we saw it initially. Customer ID 0 of age 19, which with an annual income of 15,000, with a spending score of 39, has fallen to the cluster or the category 0. And the customer ID of 2, the third row that you see here, age 20, annual income 16, spending score 6, has fallen into the category 2. So just like this, every single row, which is actually a customer in real world, has now been categorized into a different section, which means that now I can have marketing campaigns which are different for different customers. So I will not show them the same thumbnail for their Netflix homepage. It could be implemented for Amazon e-commerce as well. The landing page that you see when you search for women's clothing or men's clothing will be different based on which category you fall into. Yep, we do that much analysis. So this is how you would visualize this for our 4KB data. In this, you can see there are green or teal colored clusters here. These are the data points that actually fall into one cluster altogether. There you have the blue ones, you have purple and yellow. Actually, in this, when you had seen this, where in the initial the third slide or something, they actually look like they were in the same cluster, but the colors show that they're actually in two different clusters. There is definitely going to be some category like the spending score that actually triggered that, yes, they should be falling into a different cluster altogether. So the more information you have, we had just 5 columns to begin with, and that is not the case in real world. You will have I don't know, a lot of hundreds or maybe 200 columns, and it would be your decision as a data scientist or a data engineer to choose which are the relevant columns, and that will actually factor in your models as well. So today you would have Azure ML Studio or Google ML Studio or whichever cloud provider you're going to be using. It is going to be a drag and drop, a very playful time for any data scientist who might not have the statistical or the mathematical knowledge to actually understand this, because everything might have been automated for you, for your team members. And what happens is that once the result is out there, it is up to you to decide what does that result actually mean. You might come up with these numbers. So having just these numbers does not really actually help the marketing team or does not help anybody else in H&M and RHCA to decide which of these quotes should go on quote or tops should go on sale. So it is up to you. Everything is going to be automated. The code is going to be written for you by ChatGPT. But if you're not able to understand what does that mean, that is where, I mean, humans are now required not to write code. That's all boring stuff that's been, taken care of. Now what you need to do is understand what does the result actually mean and can you tweak it. So the very top left customers, they are the ones who seem to have a low spending score, right? But they also are people who have a very high annual income. So they have disposable income left. They can spend more. Maybe you should target those customers a lot more with maybe a higher bracket of spending income, right, that they have. Now, those who are falling on the yellow category, they seem to be spending a lot more. So maybe you can have mercy on them and target them lesser. But yeah, we would still want to make money out of every single customer. Now customers on this end have a different understanding. So the more you go through and figure out these 5 or as many clusters as you want, you can try to visualize them in a 3D way. I have the code for this that will be shared within the slides. You can actually go and turn this entire graph and see, okay, which of these customers fall under which categories, and then understand, okay, these are the things that you would write within your presentation for your team. There are a few customers who fall under this category of 20 to 40 age group, but they also are very young at heart because they keep spending a lot more. And there are other recommendations that you could come up with as a data scientist or a data engineer working in that team. So I hope that was a good understanding of the k-means algorithm. I would also like to introduce you to other machine learning models that we are using in the retail space. I had spent 4 years in Fractal in the retail industry, which is why I'm super passionate about this domain. Now, there is this thing called market basket analysis. If you research on more about this uses a very simple one-liner probability theorem. That's something that you learn in your 8th grade or 7th, based on, I think you might be a lot more advanced. But here what happens is, have you seen those case studies that come up saying, in 1992, I think they were trying to find the correlation between why is there the sale of some beer company was trying to do this. There is the sale of diapers and the sale of alcohol. There seemed to be some kind of correlation between them. Or you might see when you go shopping, bread is kept right next to cheese or butter. You would see different kinds of positionings that is when you walk into a physical store as well. You would see coats are placed next to boots, just because they have seen a pattern that people end up buying something just since it has been co-located. It helps you. Market basket analysis is the math behind it. You would want to place a certain item right next to another item because people tend to buy it if it's right, in their line of sight. I would like you to think back on the slide that we began with. Feel free to put it up in the chat if you are able to link it with what happens in the e-commerce and the online world. So if something is being placed right next to it, you would end up clicking on it, right? So that was I can't see the chat, which is kind of causing this, but you remember customers who also bought this, so also bought that. So that is the Amazon recommendation system, or the Flipkart, or any other e-commerce website that you might have seen. What's behind that? It's market basket analysis. Again, very simple. It is super easy to run that. You would not even run that or write any code for it. You would just drag and drop a box in your cloud providing system saying that, let me run this model called MBA, or you could run K-means, whichever works. But Amazon is using MBA for it. MBA, market basket analysis. The second one that we have is called Naive Base. I hope all of you have seen Gmail targeting some emails as spam and some not spam, and the algorithm that is used behind that is Naive Base. Again, this is a very simple probability theory that you use. So this will help improve your experience while you're using Gmail, and there's also the same thing that is used by Instagram. So once you have clicked on, I don't want to see a certain ad or a suggested post, it would try to go through the rest of your feed and remove similar content that you have already marked as spam or not relevant to me. I don't want to see this in my feed. So they would also make use of similar algorithms. There is the next one that is very commonly used. Every machine learning begins with regression, logistic, or linear. So linear regression is something that's, again, super commonly used. I used it in Fractal as well. We used Ridge or the lasso or edge. There are 3 different variations of the advanced linear regression that we use. So not every company out there is using neural networks or AI, but they should be by now. But however, I want to leave this conversation with a understanding that a lot can be done by machine learning, basic or advanced machine learning that is using linear regression and naive Bayes and market basket analysis. These are all very simple statistics that has been powering our economy since the 1980s or 1970s, maybe even beyond that. And all it makes use of is simple math. So what linear regression does is it helps you figure out a correlation between variables. You remember the spending score and the annual income? I can create a correlation between that, or the age and the annual income. It helps you. So this is a time where when I call it lifetime value prediction, some customers, so there is this saying in business that 20%, 80% of your sales come from 20% of your customers. There are few customers who are very loyal, and regardless of where H&M starts a new store, if I'm a loyal customer of H&M, I would definitely go to that new store, purchase something new from that, because I have a connection with that particular brand, or I feel that the brand values me more based on the kind of marketing ads that I see. So it is super critical for these businesses as well to understand which of their customers are falling into that 20% category, and they can build that lifetime relationship with them, give them offers, give them incentives to keep coming back more, and which are the customers that don't fall under this category and which would actually end up churning. So when you want to be able to predict these values based on the historical data, you can actually see that the model improves, and you can end up having a lot of optimization, like I mentioned earlier about Ridge, Lasso, and Edge. So that would be the end of your my theory session, and I would be really happy to give you this access to. This is an old hackathon. However, here we are trying to predict that customer lifetime value. A friend of mine built this, and this is still present here. You can click on this link once you get access to the slides. Here, this hackathon mainly focuses on audience segmentation, but the data is Google Analytics data. So Google Analytics, like you would know, a lot of marketing companies or data companies out there who are selling products have their websites connected to Google Analytics. Now, Google Analytics, if you've not seen this, this is a very super nested data set. So you would have page views, you would have which person clicked on the first page, then went to the checkout page, then came back and did not purchase. You would have all of those information in available to you in Google Analytics. Now, I showed you the code that I showed you was written that I did not show you, but it is linked in this slide. Was written in Python, but there is also the possibility of writing all of this code in SQL, but it's not exactly SQL, it's BigQuery ML. So BigQuery, if you do not know, is Google Cloud's data warehouse. Now think of Redshift in Amazon, think of Synapse in Azure. You would have different data warehouses present in different companies, which are based on what your team is actually using. So BigQuery has the possibility of writing all of these machine learning models in something called BQML. So BQML is simply BigQuery machine learning, and it helps you write all of these algorithms, the k-means algorithms, with simple SQL statements: create, model, and you would just end up writing it. So if you go to this hackathon, you would actually go through an entire GitHub repository where you have starter notebooks. They are super detailed. I was a part of writing that entire thing, reviewing and proofreading. My friend Lavi Nigam is the one who wrote it, so all the credit goes to him. There's also another retail Kaggle notebook that I've used to actually show you all of the EDA scatter plots that's available here. And I've also linked to some more videos on understanding what clustering algorithm is. So happy learning. We'll dedicate the next section of our conversation here on what happens when you try to move from a 4 KB dataset to a petabyte dataset. So here I'm trying to introduce you to what happens when you are a data scientist or a part of a data engineering team in a very big company, or based on your budget of your startup, whichever company you're working for. These are different stages that you would go through while running these campaigns on a large scale. So once you have access to the data, imagining it is in a, let's say your client puts the data in a cloud storage bucket, it is up to the data engineering team. So you would begin with, these are the different stages: data engineering, analysis, model development, MLOps, insights, and orchestration. So it's not just that you would do these in one go. You would also want to reiterate and relearn and reevaluate. Let's go through in detail. What happens is the data, let's say I had the very first client that we had was, say, Best Buy. Now, Best Buy gave us some data that was sent to our engineering team every Monday. And it would be the job of the data engineers to get the data from the storage bucket using an SFTP protocol. Some protocol, it would come up into our cloud systems. Once it has been dumped, I think it used to happen every 2 a.m. The moment it has come in there, it is the responsibility of the data engineers to mangle and transform that data and put it into a data warehouse in a certain format that the data scientist can actually use. So before you do the analysis, before you got those 5 cute neat columns in the 4 KB dataset, that is actually a subset. You have a large raw, with 200 columns, you would have a large amount of data set that's coming in. It is the data engineers who transform this using PySpark or SQL or any of those available tools today. The Databricks is coming up with new tools every day. You would transform the data from the raw format to cleaner format for analysis. And even once the analysis even once the data is ready for analysis, you know that as we went through, there are different models to go through and understand, okay, maybe I need to still remove the null values. You want to go through a certain amount of preparation for it. And then finally, you end up saying, okay, this is now a very clean state. Let me use k-means algorithm, or let me use naive Bayes. Whichever algorithm you come up with, you would have to go through again the training phase, evaluation phase, testing phase. So training and testing, you all know about how to split the data. There are different methods to recommend how to go ahead and split your data as well. But once you train for it and have it in motion, you don't stop there. You have to keep monitoring your model. So you would want to evaluate and test it and serve it out on an endpoint that your team can use. But that your story and your job does not end there. You have to keep monitoring whether that particular model is working for the new data that comes in. So as and when the data keeps changing, you would have to keep monitoring. Do you have to change something? Hyperparameter tuning has to be done, or maybe the model itself changes. So that monitoring keeps happening, and this is based on whether or not your team is moving from a maturity level 0, 1, or 2. So when I say MLOps maturity level 0, what happens is you're working with offline data. You have everything ready for you. Batch data is available to you. You don't have a lot of customers. Maybe your team is a startup working with just 1 or 2 clients. You can go ahead with this kind of an approach where you are on a zero level, where you don't have continuous integration or continuous deployment, and there's no monitoring done. You've built something and it's available to the 1 or 2 customers that you have. But if you keep on increasing your number of clients in your clientele, you would want to be able to manage the continuous integration and the deployment, and retrain your models for different kinds of data that you have available. So just a second. Now in this, what happens is that there can be, so like I mentioned, data is coming at a certain time. So you would want to trigger and automate all of that data engineering and analysis process that are in place. You would want to actually trigger it automatically. I mean, you wouldn't want to wake up sorry, at 2 a.m. in the morning and run your data pipelines to move it from a raw data set to a clean data set for your data scientist. You would sorry. So when I say there is a continuous integration and continuous trigger, and CD stands for continuous testing. This trigger can be like, say, 3 or 4 lines of Python. If I were to use Airflow, now Airflow is an open source thing. You would have paid versions of that in Google Cloud as Composer, or Astronomer is also a paid thing, I think. But Airflow is open source. You can try it out. Write a 3-line Python code in Airflow. It is basically called a DAG. This can actually take your, let's say you want to move your data from a GCS bucket to BigQuery. So I can write a DAG that will actually trigger every day, every morning, or every Monday at 2 a.m. to move data from my client's GCS bucket to my team's BigQuery table. And I can do that. I can schedule it, and I can forget about it. So that is where you've actually matured, and your team is going to make use of a lot of automation. That entire ML, all of the different stages that you saw, these are different stages. Each and every stage can have its own sections automated. You wouldn't want to waste your weekends and your sleep over things that can be automated. So in production, once it goes, there can be more validation and monitoring that happens, again with more continuous testing. So you would see that the data goes from offline to online. You would have dynamic data coming in. Let's say you have returns. Every product goes around with, say, 30 days of return time. So that data has to be taken into, let's say, Redshift, that is your data warehouse. And the data engineers will be responsible in giving us an aggregate. And from that aggregated value, you would see a very clean, very frequently accessible, readable data set. So the cleaner your data is, the lesser time it takes to read your data and get the data out of your database or data warehouse, wherever it's staying. So all of that transformation happens for online data. Once you've moved to the level 2, here you have rapid and iterative. Maybe every hour you have a new version being released, and there will be model monitoring and versioning that is taken care of. We also need maybe some versioning for the data as well. But the system becomes very robust. You would not have to do much more than making sure that you've made the right decisions from the beginning, or you would want to change that based on the results that are coming forward. And it's not that you can just sit back and enjoy. You can work on the things that you actually care about, instead of being worried about the infrastructure and whether or not it's being auto deployed or auto build is happening. So these are the different stages that you would want to move based on the availability of your resources and headcount. And resources, when I say resources, I mean the cloud infrastructures. Every team comes with a budget on how much they can spend for the resources on cloud. So based on that, I think if you're able to access all of that, you can build your ML pipeline in a way that is mostly automated, but you can also choose to evaluate it and change it based on the use case you have. So and also I've got more on this. There is a Google machine learning best practices for each of these stages. I know I've just given you a short introduction, but there's a lot more to read about this. And just to end, I also would like to share that it's not always data scientist as a job. I know there's recession happening. There's a lot of folks coming out of colleges right now and universities looking for jobs. So I wanted to bring this out there, that there are different. So as I mentioned, there are different stages. Every single stage requires a different skilled person. So if you're interested in MLOps, that is the versioning and the monitoring and creating all of those triggers and DAGs, you would want to look for jobs with these buzzwords or titles. So you could be a data architect, or an ML engineer who's actually building the application and is more focused on the ML side of the things versus the engineering, the infrastructure side. So these are two opposites. There's also somebody who would be responsible for the data warehouse, but a lot of these things are being automated, so they get easier based on your understanding of the tools of Databricks or any other tools that are existing, Snowflake, based on the tech stack. It keeps varying on the tech stack keeps varying, but the roles are similar. There's also these 4 different roles. So currently what I am is the AI product manager, because I'm working on integrating LLM models within our enterprise data, and the product has to be such that it is, again, personalized, customized for every single user or developer within our company. So TELUS is a very big organization, and you would have a lot of different choices and recommendations that would come up for the individual developers. So that's my job here. There's also the visualization that I'd shown you. So there's different tools that people use in the enterprises. It could be Tableau, it could be Power BI, or any of those different mechanisms. Like if you want to make dashboards, it's really nice. And Google right now has acquired Looker. So you have Looker Data Studio, which is one thing right now. There should not be common there. But if you want to be able to play around a lot more on a day-to-day basis, I've seen Aritzia come up with a Tableau expert. You would have those jobs as well. There's also something called a data AI or ML advocate. This is what I joined Google as. This is something that helps people, that is the developer community, learn more about what are the different tools available for machine learning. How can you go ahead and do different machine learning stages while using these products? And it helps you connect to the developer community a lot and come up with feedback to the product managers. That is what I am right now. And it's like the advocates are a bridge between the developer community and the product building team. So there's also a digital analyst. I've seen a bunch of these things when it comes to searching jobs in LinkedIn. So I hope you all liked that, and if not, please let me know. This is a feedback link for this. I would love to improve my presentation skills. And there's also a blog version of this talk on my Medium. I've shared that with Vincent. He will be putting up in the chat. And feel free to reach out to me for anything related to data science or product management in any of these socials. I guess it's time for question answers.
Yes, hello, Julian. You're right. It's time for a Q&A. And as we have lots of questions, I would say let's start right away with the first one, which would be, would you recommend clustering for fraud detection, or is there another attempt you would choose?
Fraud detection, I would use another algorithm altogether. There is different methods to do that. So I remember one of my colleagues within Google, Polong, if you were to go through his GitHub, we have a lot of options to run fraud detection, and it's not, you can use this. So again, like I mentioned, data science is more of an experimental science. You can try to recognize patterns, create clusters, and then figure out, okay, every two, nobody expects there to be a transaction at 2 a.m. But suddenly, if you have that, there are machine learning models within your banking apps that can actually trigger fraud alerts based on transactions on different timings, different. So it might not be times, it can be even locations. Like you're always living in Europe. Suddenly, if there's a transaction from your credit card at a different location, that would be triggered. And these things are automated, which is why your apps would be like fraud alert. So yes, you can use clustering, but there'll be a lot more algorithms available out there based on the use case. I can think of Bayesian networks. I can think of, I think there's also sequence, like based on the sequence of your transaction, every time second, like the timestamp, every millisecond is actually recorded. And we were actually going through a data to AI campaign, and in that we went through creating generating synthetic data, where we would want to the data was coming on a streaming process. So you had streaming data, and every timestamp was like milliseconds were changing, and the moment you had a fraud, all of our pipelines would trigger that as a fraud. So I think sequence matching was also used. These are the few things that come to my mind right now. But yeah, based on our use case, we can keep changing that.
Thanks for that insight. And let's move on to the next question.
Sure.
What do you think about A/B testing, split testing? Is it necessary to optimize your campaigns, or is it too much work for the end results?
Again, if your domain requires A/B testing, I know a lot of us feel that we have over-engineered and used A/B testing a lot more than necessary. But it is very helpful for websites, and you all know how Netflix uses different thumbnails for different users. It does A/B testing to a different level altogether. Now, for example, you have Stranger Things, you watch Stranger Things, I would see a very different thumbnail than what Benedict would see. And that's because they do that kind of A/B testing for every customer. And A/B testing can be used. So like I said, if it's not a streaming platform, it could be maybe an e-commerce platform. And it is good to use for those use cases a lot, but it is not really a great thing when you're using it for retail, or retail as in when you're trying to do something internally for marketing campaigns. Definitely go ahead and use it. And if you see that there is a change that is coming, you're able to actually get better results, go for it. If your team feels that there is absolutely no use in this kind of understanding or output that are coming out of it, don't go for it. It is like I mentioned, right? Data science and machine learning, everything is like trial and testing, and what works as best practices for one team might not work for another team. So always know that you're based on the number of people that are there to evaluate the results, to test it out. It is also expensive to keep running out new and new A/B testing modules. You might want different versions of it to be launched based on the timeline that you have access to. So go for it if it works. But yes, it is useful for a lot of people. Yes.
Thank you. Also, nice example with the Netflix thumbnails. Yeah, so sort of that. And hey, maybe coincidentally we have exactly the same watching and browsing habits, so maybe we have the same thumbnails.
Absolutely.
Who would know? All right, but maybe you know the answer to the next question. What is the main difference between great and average data scientist? I mean, for soft skills, not technical, which everyone can learn. So like the ones that are not that
Oh, yeah, absolutely.
teachable, but more.
Yeah. I guess I've started my career as a front-end engineer, moved on to being a full stack, and then a data scientist, and now a product manager. I believe the one thing that I can give from my experience, there are other great data scientists out there who can share more, is being curious and asking questions. I think there are people out there in the industry. Tech has a very bad rep out there, but I feel it is not the case. The developer community, the data science community is super kind. You can ask questions, build your communication skills so that you have a rapport with the cross-functional team. So though I was in a team that was supposed in 2016, I was focused mainly on building widgets and websites. But I built a friendship, a rapport with the opposite team, that was the data science team. And that, having those regular conversations, being friends with them, being friends with the testing team, can actually come up with these ideas and proposals and figure out, just be curious and have those conversations, lunches with a completely different person who's working in a very different team. It helps you see and connect the dots and see the big picture. That is the one thing that I've always done in my career. Like, I'm not a person who wants to just, like, I know I'm a speck in the universe, but I would still like to zoom out and see the big picture and see, like, where am I and why am I doing what I'm doing? Like, you need to be able to, take a pause and ask these questions, and people will answer. I have always had people being really kind to me, where they ask. I know it's annoying to ask the same question to different people, but I do that and get different answers. So it helps me understand more about why I'm doing what I'm doing.
Like how all the gears that are grinding are connected to each other and move the biggest the biggest gear. Yeah, so it's very nice. Thank you for that answer as well. And let's go on to the next questions about security. Are there privacy concerns when using clusters, like a data leak, for example?
Not within the model itself, but you can have privacy leaks if you've not handled it properly while the data engineering section, if you remember. So whenever you're building these different so here, if you see this particular data engineering section, here is where you would want to go ahead and implement those. So if you have PII data, that is personal identification information, the data that you have for the identification of a customer, their name, their location, their credit card details, these are all super critical, and no company would allow the sharing of this when you're building these models. So every team would go ahead and use some kind of technique or mechanism to mask that data. So let's say you have credit card data. So I've worked with fraud detection algorithms where the credit card data would be masked and morphed into some random string. I would not even know what that string looks like, and that schema is just basically random string. When I'm testing and building synthetic data as well, credit card data, the location data, all of that has to be privatized or masked. You have to be able to make sure that before you have started implementing I was trying to show my screen, but before you've actually implemented the model, it happens before this. Like in the data engineering side itself, you would want to, and the analysis, before you've reached this analysis stage itself, in the data engineering side, you would go ahead and remove that data, use dummy data, and then make sure that the data that you receive once you have reached the model building stage is secure enough for you to use, so that you don't end up losing or using anything that is going to be risking your job. I hope that answers.
I think so. At least I understand it. And I would say let's go on to the next question. Do you sometimes use AutoML in your projects?
always go ahead and try that, because sometimes it comes up with results that you would be surprised to see it. But if you know more about the data that you have within your data set, you would want to go ahead and use a model that you feel is perfect for that. However, there are times that AutoML comes up with these things. So I've tried that with images. I've tried that with tabular data. It would come up with linear regression and all. All of this is automated. Everything I told you today can be done with a split of a second. Like I've seen ChatGPT plugins that say audience segmentation. Like go ahead and search for AI PRM plugin. There is a plugin and there is a way to automate everything that I told you and a lot more. So AutoML would actually come up with like, that's your first draft. Like maybe this is a pattern, or maybe this is a result that I want to build. That can help you get rid of that first block that you might have. Like everyone says, writers have a writer's block. Data scientists have a block in understanding which model can be, useful for this, unless you go ahead and do all of the EDA. So the AutoML will actually help you do something initially, and then you would want to maybe tweak it and have a custom version of that. It's just linear regression. Go ahead and use AutoML for linear regression and then change it to something different. Maybe you want to go from basic linear regression to ridge or lasso or edge based on your the hyperparameter tuning that you can do. So definitely give it a try. But mostly if you have a huge data set and a huge client to report to, you would want to put an effort and change it based on the outcomes that you need. Sometimes AutoML is good, but it might not lead you to that end objective that you want.
And also scales with experience, I would
Yes.
say. So yes, thanks for that answer as well. Let's go on to the next question. What MLOps tool do you use for CI/CD pipeline?
So it again, thank you for that question. So I've used Dataproc. So Dataproc is basically where you have different versions of that. You have clusters, or you have the serverless Dataproc as well. This is basically where I write my PySpark scripts, where I could write my PySpark scripts or Java jobs that will help transform the data. So CI/CD is basically continuous integration and continuous deployment, where this will just help you integrate and bring the data from one place to another. You can use Composer so these are things that when I say these words, these are Google products, but that does not mean that Amazon does not have them. Amazon and Microsoft have their own versions of this. Composer, when I've used that, I can go ahead and trigger and schedule them, all of these different jobs that will help run the different models that are. So let's say I have a PySpark job. I have a blog about this in Medium as well. I have a PySpark machine learning job that is existing in a bucket. I can tell the DAG in Composer to pick up that particular machine learning .py file and run it on the dataset that is existing somewhere else. So I don't even have to go to those places. I just have to write this in Python in a small DAG, where it'll say, this is where my data lies. This is where my machine learning algo function has been written. Run it on this and then dump that result in a different place, where I can connect it to a dashboard where I can visualize all of the results that has come out of it. So all of this can be done by a very small Python file, and I can run that on Composer, and I can trigger that on a daily basis based on my requirement. All of this can actually come up as a result that you can see, and the dashboard that you build for yourself will have, so I had hourly deployments, or I had daily deployments, and this is how I'm going to monitor it. These are the times that I would want to change the integrations or the triggers. And you can go ahead and do this using a wide variety of tools, but Airflow, being open source, is very easy to get started as well. Their documentation is really up to the mark. You have to go through all of that if you have not tried it. So feel free to experiment.
But yeah, thanks for that insight as well. We still have some questions, but sadly we've run out of time. So maybe to the audience, reach out to Julian on her socials. I think she will gladly answer the left open questions. And to Julian, thank you so much for the talk. Thank you so much for the Q&A, and hopefully see you soon again. Bye. And before we move on to the final talk of the day, 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to machine learning and the final talk of the day, actually. The speaker is practice lead in data and analytics at Centric Consulting. She specializes in data storytelling, data strategy, and visualization, describes herself as a big Disney nerd, and she loves to plan and going on vacations together with her 2 daughters and husband. Welcome, Becky.
Hey everyone, thank you for having me. I'm jealous of the Star Wars shirt. I wore mine yesterday, didn't wear it today. We could have matched, but that's okay.
Yeah, next time we need to discuss this beforehand so we can go in partner look in the. Okay, so we already have a challenge for the next live day, but let's talk about today's live day. Becky, what are we going to learn from you today?
Well, I know for all of you, you're at the end of a long day of talks here. I live in the US, so I'm just starting out my day. But I thought we should wrap up the day with something fun. Let's talk Disney a little bit, but not only fun, let's talk about all this great technical machine learning knowledge that we've accumulated throughout the day. Let's talk about how to make that actionable, how to get it in the hands of people so that they can use it. We'll use Disney as a fun example, but the principles that we're going to go through can be applied to a wide variety of topics. So that's the goal, is to learn how to make things applicable for the masses.
Right. Then good morning to you, Becky. And I would say, without further ado, stages are yours.
All right. Thank you. Okay, we're going to talk Disney today, and I know a lot of you are probably closer to Disneyland Paris than to the one in Walt Disney World, but that's the one my family visits most frequently, and it's the one I have the most data for. So that's the one that we're going to talk about today. How can we hack our vacation, and what does that mean? How are we going to make our numbers powerful and meaningful, but also fun? Let's talk about me a little bit. A lot of my presentations are pretty personality driven. So you're like, who in the world is this person from smack dab in the middle of the United States? So I'm Becky Dillon. They already mentioned who I work for, so that's not a big deal. But my background's actually in biomedical engineering. Why is that important? I'm a problem solver at heart. I will always be an engineer, training my daughters to be engineers, just like planting those seeds a little bit every day. And that's how I approach data problems as well. It's always problems to be solved, not just algorithms to be built, etc. I worked here in the US for the Department of Veterans Affairs for about a decade, purchasing and helping maintain medical equipment for them. And that's where I really discovered my passion for data. Is a lot of this could be done better if we were doing it in a data-enabled way. And so then hopped over to the world of consulting, where it's a lot easier to stay on top of the newest tech stacks and etc. And so now I specialize in data strategy and road mapping. And so how do companies and individuals make the best use of their data, from an architecture perspective to data science to analytics to visualization, all of the things helping do that road mapping. It's my only animation, don't worry. But also, I am a mom of 2 young kids. This is us last July on our last visit to Disney World. I'm a lifelong Disney fan, as you can probably tell by my surroundings here at my home office. And I'm a vacation super planner. I tend to have 3 or 4 vacations planned in advance in spreadsheets regarding what we're going to do. So right now we're going to a family conference in Wisconsin in July. And then we're going to go see some national parks on the west coast of the US in August. And we're going back to Disney in September. So those are my current 3. I do a lot of blogging. So I'm all about making data accessible to non-data people. So I do 1 or 2 posts a week, typically 2. And I have a YouTube series where I explain Disney data and how to use it in vacations. And that's wildly popular. So in that sort of alter ego, I've specialized in crowd and touring analytics and really vacation optimization. When you hear optimization, we think machine learning. Well, this is why I'm here today. This is why we're going to talk about it. Also, I'm a mom in search of one decent family photo. I thought here at the end of a long day, we could use a fun through line through our presentation. So you're going to see all of the Disney family photos that I have taken in search of this one goal. Okay, we're going to see that as we approach data science problems in general, even analytics problems in general, you always want to approach them with a goal in mind. You don't just wade into a set of data and say, tell me what you will. You need those goals to be able to direct your discovery. So for vacation, my goals are to avoid crowds. Disney gets more and more crowded every year. How do we avoid those crowds so I'm not spending hours in line with cranky kids? How do I save money? Disney vacations are incredibly expensive. And how do I actually enjoy this vacation? Because even if the parks are empty and I'm not paying a lot, we could be having a miserable time, and that's no good either. So this is sort of my three-legged stool of goals that I want to accomplish using data in Disney. And also I want to take that one decent family photo. This is a ride in Epcot, and I had my 1-year-old daughter in my lap. I thought it was going to splash us in the face. Little did I know it was actually going to take our picture. So no good family photo there. So what's the problem? Why is this an optimization problem that humans can't do by ourselves? That's really where we need to adopt AI or ML, something that our brains just can't comprehend. How can I prove that this is something our brains can't just plan on our own? Let's take, for example, one day at the Magic Kingdom. Things I need to know to help avoid crowds and save money and enjoy my vacation. What's the park capacity at the Magic Kingdom that day? Is it going to hit that capacity? So what's the park attendance by day? Park capacity has almost reached 100% again post-pandemic, but there are significant staffing issues here. So it's not always fully up to 100%. And then attendance is going to vary within that. It's not going to hit capacity every day or ever at all. So what's that actual attendance? How many crowds will be attending? Beyond that, how many people are going to attend per hour? A lot of time on vacation, people don't like getting up at the crack of dawn. So you're really going to see some peak hours of attendance. And what are those? We have variable ticket costs here in the US parks. So however crowded Disney thinks the parks are going to be, or where they want to distribute crowds, they'll rank up the ticket price. Or if they think that no one's going to be there, they'll ratchet down the ticket price. They just released a huge summer ticket deal because they think no one's coming this summer. So how does that impact things? What are the operating hours of the park? And how does that impact when people will decide to go or what days? Which of the 29 to 39 attractions operating on a given day are people going to go to? How many of them are unexpectedly down? Operational issues. Which of the 31 to 33 different dining locations are they going to choose to eat at? How can I save money at these dining locations? How do I help my children avoid the 9 to 13 shopping locations so I'm not partying with all of my souvenir money? I want to keep that for myself. What are various dining preferences? So we have how many dining locations there are. Obviously, people don't distribute themselves evenly across those. So what are their preferences? Where's the quality there? What are the highest quality dining locations? What about attraction popularity? How does that differ? We're not all going to go ride Dumbo. Where are we actually going to go? Dining popularity, which is weirdly divorced from dining quality. I blame influencers for that. And upsell opportunities. And how can I avoid them? Or do I want to take advantage of the ones that are a good value if they help me avoid crowds? And on top of this, I have to make reservations, and so does everyone else if we want to visit the parks. And how do I use those to my advantage or try to get around them in order to meet my goals? That's a lot of data to either collect or predict or get my head around. And as a human, I can't do all that. This is where I need the machines to come in and help me. Not just that, that's just Magic Kingdom, which, by the way, is where we took this family photo. Also, Not a great job. Can't even see my daughter's face. Okay. But in addition to Magic Kingdom, we've got Epcot, we've got Hollywood Studios, and we've got Animal Kingdom. So out of all the Disney parks in the world, Walt Disney World has the most in a single location with 4. And bonus, they have 2-ish water parks. Not both are operating all the time, so I'll go with an ish. One shopping district called Disney Springs, where you could easily spend a whole day and your entire vacation budget. One Galactic Star Cruiser that is shutting down at the end of September because of its lack of popularity, mostly because of its cost. If you haven't heard of the Galactic Star Cruiser, it's a big, giant warehouse building, but the inside is themed to a spaceship, and 2 adults can pay $5,000 to spend 2 nights there and essentially cosplay Star Wars for 2 days and 2 nights. And it's actually really, really cool. But the populations of avid Star Wars fans and those that have $5,000 to spend on a 2-night experience is apparently very low. And Disney did not predict this well. So that's closing at the end of September. I know we're all shocked. But you have 34 other resorts where it's also easy to spend a day. Like in the pool, there's one at Epcot, near Epcot, called Stormalong Bay, Sandy Bottom, Pirate Ship. We have Animal Kingdom Lodge that has savannas of African animals just roaming about that you can relax and watch. That one's my favorite. So are people going to spend their time at the resorts? Are they going to go shopping? Which park are they going to go to? When they're at that park, what do they choose to do? How can I predict all of that so that I can have the best experience and avoid all the rest of them? That's the trick. So I'm going to pause for a minute. I don't know if I can see the chat, but that's okay, even if I can't. I would highly encourage you to take a minute to brainstorm, because I don't want my brain to do all the work, especially this early in the day for me. What data sources, I've sort of laid out this problem statement and our goals. What data sources would you seek out? You're all a bunch of smart people, to try to avoid those crowds and to spend less money. So brainstorm, drop some ideas in the chat so everyone else can brainstorm along with you. And in about 30 seconds, I'll flip forward to show you the ones that we actually use. I need some Disney tunes here. Next time I'll be prepared. Okay, 10 more seconds to try to outguess what I'm going to show. Okay, what data sources do we want to collect? Knowing our goals, avoid crowds, spend less money, enjoy vacation, but also knowing the gigantic size of this problem and all the data that we're going to need. Okay, you've run out of time. Here's a lot of what goes into the answer. Number 1, crowd behavior in the US is significantly different than in Europe. That's because y'all are much better at vacationing and taking time off from things than we are. We just burn ourselves out all the time. It's super great. But number 1 predictor of attendance at Walt Disney World is school calendars, because the core demographic for Disney visits are families with kids, and a lot of those families don't want to take their kids out of school. It's interesting, post-pandemic, behavior is actually statistically quite different. We can see that parents are statistically more willing to take their kids out of school. Maybe they realize there's more to life than just sticking to a school schedule all the time. But even so, it's still the number 1 predictor. When all of the schools in the US are out for a significant period of time, think Thanksgiving, winter break, spring break, long weekends. Here we have President's Day, Martin Luther King Day. That's when the parks are going to be the most crowded. When everyone's in school, like right after Labor Day, is when almost all school districts are in session, or in between Easter and Memorial Day, parks are empty because no one's taking their kids out of school at the beginning or the end of school year. So that's our number 1 predictor. Next is economic data and travel spending in general. So right now, there's a lot of fear of an economic slowdown, and crowds are way down at Walt Disney World. This is an expensive vacation, so we can use that as a pretty good predictor. You can also look at travel agent booking trends, cancellation trends. 2024 vacation packages released today. It's the first day to book a 2024 Walt Disney World vacation. So we're starting to look at first day demand and what that can tell us about what 2024 is going to look like. Prior years of actual results. Prior years are really good predictors of present and future years. Behavior doesn't change that much, but we did have this remarkable shift with the pandemic and how that impacted behavior. So our prior years are just starting to rebuild in sort of this new world. Weather trends and forecasts, a lot of people don't like visiting when it's 95 degrees and 100% humidity. Imagine that. How does that impact things? Operational info. When big rides go down for refurbishments, how does that affect park capacity and crowd patterns? And then on the right side, so all that left side is readily available information that we could pull from public sources most of the time. Travel agents, a little less public. On the right side, we have data that we're actively going to get or collecting ourselves. So Disney has an app on your phone where when you're in the park, you can look at their posted wait times. They refresh at least every 5 minutes, usually more frequently than that. Very easy to scrape those posted wait times, and you can pull it up from anywhere. I could look here in St. Louis today. You could look in Europe at what the wait times at Walt Disney World are right this very second. Most of the parks aren't open yet, but we can scrape those and see exactly what Disney thinks the wait times are. But also, we created a mobile app so users could submit their actual wait times, because the difference between posted wait times and actual wait times is different. Disney is quite motivated to post different wait times than what you're actually going to wait. A lot of that's psychology, so that you think you're waiting less than you expect to wait, but also some crowd distribution. We have an in-park testing team where if we're like, we just really don't understand what's going on with Space Mountain, can you go ride Space Mountain 6 times in a row and gather us data? Rough job. Post-visit user surveys talking about enjoying vacation. You just went to Disney World. What did you think of the places you ate, the attractions you experienced, etc.? Regularly scraped cost info, things like menus, extra experiences, and regularly scraped available reservations, whether that's a dining or hotel, resort, etc. So what's available? If nothing's available, probably going to be crowded. That makes sense. Okay, that was a lot of data. I hope some of you guessed some of these, but that's a lot of the big predictors and what we use to piece together an answer. So how are we going to use those now for each of our goals? You're like, oh my gosh, we're 20 minutes in and we're just getting to the first goal. Don't worry, it picks up from here. That was sort of the important foundational piece. Now we get to the fun application. If we want to avoid crowds. So this picture is taken before the park even opened on a day post-pandemic when the park was about 50% capacity. And this was still the crowd, super early in the morning. And I don't want to be a part of this ever. So how do I avoid that? This is where most of the other presentations today would probably spend the most time talking about all the algorithms that go into this, etc. Really, the tech stack here is not impressive. We're using a lot of Python. We're doing some random tree forests. But you've had a lot of algorithms and tools, etc. today. We're going to talk about, once I have that, what do I do with it? And so we're going to get into the what we do with it. And one of the big things that we do with it is this crowd calendar. So we can see, I'm just looking at the next sort of 6 days, starting on Saturday of this week. I can look and see that on a scale of 1 to 10, how crowded the parks are going to be, at least our prediction. I can see the park hours that I can expect. I can see if park reservations are available. Since they're all green, that means they are. None of the parks are sold out. I can see ticket costs. That gives me a little bit of an idea of how much it's going to cost me, but also how crowded Disney is going to think it's going to be. Plus also special events, all of this information, and we do it for a full calendar year in advance by park for Walt Disney World, Disneyland, which is the one in California, and Universal Orlando. So that's cool. It's a calendar. It's still a bunch of numbers, not particularly applicable. So let's talk about what it means and how we actually get those numbers. And I'm sort of presenting it backwards, because what we actually do is we create predictions for every attraction at every park on a 5-minute increment through every day of that calendar year. Then we gather those up to get peak average wait times for each attraction. And then we gather those peak average wait times to create this overall park number on a scale of 1 to 10. But I'm going to talk about it from the top down just because that's a little easier to comprehend. So here we can see some of the attractions at the Magic Kingdom, as well as those 10 crowd levels that I talked about. And we sort of force these onto a bell curve. So those level 1 days, super, super rare. Like those almost never happen. You're going to get 1 or 2 of those in a calendar year. Level 10, the exact same way. This is like Christmas Day or New Year's Day, the very most crowded the parks are going to get. Everything else, most park days are going to fall in that 4, 5, 6, 7 range. Bell curve. That's how we purposely build that. Bonus, it looks like a roller coaster. Okay, we were getting a little too mathy there for a second. So what does this mean from an application perspective? For the US parks, the least crowded the parks will ever be in every calendar year for all of history, I'm just going to call it, is the week of Labor Day, because that's just when schools are getting in session. Everyone's already spent a bunch of money on their summer vacation. No one is at Disney World. By the way, this is the week my family goes to Disney World every single year. We're going this week this year. So I'm using this for my own planning purposes. So we can see that on Thursday, September 7th, Magic Kingdom is going to be a crowd level 2. What does that mean? That peak average wait time at Seven Dwarfs Mine Train is going to be between 60 and 80 minutes. That still seems like a lot of time. We'll see how we play with that later. You can see those predicted wait times for each of those attractions on a level 2 day. Now let's say, based on whatever my family's schedule or my own wishes, we decide to go the week of Christmas, which is the most crowded week of the year, right between Christmas and New Year's is always the most crowded. I can see that if I go to the Magic Kingdom on Wednesday, December 27th, that then those average posted wait times are going to be much, much, much higher. So instead of waiting 60 to 80 minutes for Seven Dwarfs Mine Train, I'm going to be waiting 200 minutes. And even if I go down to Winnie the Pooh, which is a less than 1 minute ride, I'm going to be waiting over an hour for it. I'm going to be waiting almost 3 hours for Space Mountain, etc. Yikes, I don't want to be there on this day, but a lot of people do, or they just don't know better. So that's the crowd level 10 day. What a crowd calendar is good for is even if I have to go on this week, because maybe I'm a teacher and I'm just as much a slave to the school calendar as my children are, which I'm not, thank goodness, bless teachers, gotta love them. I can still sort of play with how crowds behave and avoid as many crowds as I can within my constrained dates. So instead of going to the Magic Kingdom on the 27th, if I go on the 26th, I'm seeing about 3 crowd levels less, which is going to make a pretty big difference across the course of the day. And then I can sort of minimize my crowds. I still end up at Epcot, I believe, on a crowd level 10 day, but I've minimized them as much as I can within my constraints. So still useful at this level. Now we can dig a little deeper and we can see what our algorithm actually outputs. And so to do this, I've pulled 2 different attractions. On the left is Seven Dwarfs Mine Train. This is a big headliner in Magic Kingdom. It's almost the most popular attraction. Tron Light Cycle Run is the most popular, the newest, but it also uses a virtual queue, so you don't see this wait time behavior. And then Dumbo, which is a classic, not very popular, though, doesn't get huge wait times. And we can see the difference in behavior, and you can see sort of the granularity to which we predict the wait times at these attractions. Top row is on a crowd level 10 day that I picked at random. Bottom row is a crowd level 1 day. So Seven Dwarfs Mine Train on a crowd level 10 day, as soon as the park opens, it's up to an hour wait, just immediately. It has a weird little dip slightly after 10 o'clock. So that's interesting. Maybe we could take advantage of that. And then after 6 p.m., it starts to drop again. People are tired of the crowds on a crowd level 10 day. They start to go home. So then I start to see some trailing of that wait time. Dumbo, on the other hand, on this crowded day, doesn't have people immediately trying to go to it. No one's like, yes, here I am, going straight to Dumbo. Instead, they're writing other things, and its wait time doesn't even start to go above 0 practically until after 10 a.m. And then it actually takes longer for it to go down as well. But if you look at a crowd level 1 day, that behavior is much, much different. Everyone rushes to 7 Dwarves Mine Train still. But then it's a crowd level 1 day. There's less people. There just aren't more people to keep rushing to 7 Dwarves Mine Train. But everyone's trained in their head to go straight there before the wait times get bad. And then the morning actually has the worst wait times of the whole day. Oddly, Dumbo peaks on a crowd level 1 day early in the day as well. And the rest of the day is a cakewalk. So imagine these graphs for every attraction. So there's 40 of them in the Magic Kingdom, and then 20 in Epcot and 30 in Hollywood Studios and 20 in Animal Kingdom, not quite that many, for every day of the year. And if my brain tried to compute all those and create an optimized day for myself, I would come to a screeching halt and never be able to do that. I can see the dips and know when I'd want to go, but I can't keep track of that for a whole vacation. So again, we use the computers to generate these, but we're also going to need to use the computers to help us understand how to best utilize them as well. So now we're going to see how to make it work for real humans. And because I'm so courageous, we're going to try to do this in a live demo. But I have the slide backups because I'm not that courageous. I'm not dumb, I'm just bold. So let's say that we're just all really inspired and can immediately buy plane tickets to fly over here to the US. And we really want to go to the Magic Kingdom on this Saturday. We'll give you a couple days to get over here. I'll meet you there if all of you come. So if we're staying on site at a Disney-owned resort, we get early theme park entry, which gets us 30 minutes in the park before those off-site guests get to come in. 30 minutes doesn't sound like a lot. This is actually a huge difference when you look at the touring plans and see what you can do. But we'll say that we don't have time to actually get a Disney resort since we're traveling on late notice. So if we don't, our park hours start at 9 a.m. and the park will close for the night at 10 p.m. We'll say that we're just going to make the most of our day and stay there the whole time. Then we can pick what attractions that we're interested in. If we were in a room in person, I would let you all pick because that's more fun. But since I can't see you or your chat, I will just pick. And I will say we'll go on Big Thunder Mountain Railroad. That's a classic. Space Ranger Spin is where you shoot little lasers. That was one of the pictures that I showed. And I could crush all of you at that. So we'll do that one. We'll do Dumbo. We got to do Dumbo. I won't make you sit through the Hall of Presidents. We don't even want to do that, so you certainly don't. Haunted Mansion. It's a small world. Hopefully we'll get stuck and hear that song for hours. It's actually my 4-year-old's favorite. We'll go on a riverboat. We'll spin in teacups. Magic Carpets of Aladdin has actually averaged over 50% unexpected downtime every day for the past month. So since I know that, we're not even going to try because it's just like Dumbo. We will do Winnie the Pooh. We probably need to meet some princesses. We're not going to do Cinderella, but the new Little Mermaid came out, so we'll meet her. And Princess Tiana and Rapunzel are pretty cool. We got to meet Mickey. Peter Pan's Flight is a classic. You have to do it. Pirates of the Caribbean. I won't make you ride the carousel. 7 Dwarfs Mine Train we talked about. Space Mountain. We can explore Tom Sawyer Island. No one wants to ride the Speedway. It just smells like gas. We're not going to do Tron because we're not going to mess with the virtual queue. We can ride the railroad. Okay. Bonus at the top, we can also choose some shows or parades or diversions. I like how we call that. We want to see the afternoon parade. That's really cool. There's a fire-breathing dragon, but it doesn't breathe fire right now because the one in California caught fire and burned down. So they decided that wasn't very safe. We'll want to see the fireworks, but we'll try to catch the Dapper Dance. Okay, let's proceed to our meals and our breaks because we definitely need some meals. Let's go real fancy. This is like 70, 80 bucks a person. And there's no way we're actually getting reservations, but we'll pretend at noon we're going to go eat inside the big castle. The big castle right here. Yeah, there we go. I have the Lego version. I have 2 Lego versions actually. Hobbit scale and wizard scale. Okay. We're going to eat at Cinderella's royal table, but then we will have spent all of our money. So we will eat dinner at Columbia Harbor House. This is actually one of my favorite places to eat dinner. And I'm American, so I eat dinner a lot earlier than all of you, probably. And we'll eat there. Columbia Harbor House, if you ever do visit the Magic Kingdom, there's a second story to it, and almost like the stairs are right by where you order, and still almost no one goes up there, I guess because they're tired of walking. So it's a perfect spot to just avoid all humans while you eat your meal. Okay, no other breaks. We don't get to break the rest of the day. We're just going to do all of the attractions. Okay, now I get more options. Hooray, my plan was created successfully. Step 1, never know, that could have gotten worse. We can buy Lightning Lane access via Genie Plus. We'll talk about that later. Or Lightning Lane access via individual purchase. These are two different things. I don't want to spend any extra money. We're not going to do that. I can tell it my walking speed. So if I'm going with a kid in a stroller, I probably have a very relaxed pace. If I'm going by myself, I'm speed walking through that park to make the most of my day. But we'll call ourselves average. We can also, within certain reason, minimize waiting or minimize walking. We're still overall working to minimize the wait. But if I move that slider all the way to minimize walking, it's not going to make me ping pong all across the park and walk 12 miles in a day, which is my personal average on Disney days, by the way. So I won't make you all do that. You'll have just come over a long cross-Atlantic flight. So this is all the attractions we chose in the order we chose them. So it's not in any specific order right now. And at the bottom, we have several options. I'm going to go ahead and click this one because we don't know how long this is going to turn for. It depends on what kind of day AWS is having. So hopefully it's having a good day. The top button there that I clicked was optimize. So it's going to look at all of those curves for everything I chose, for this day that we chose, for the hours that we chose, and come up with a plan that minimizes the wait time without ping-ponging us across the park. The second option that disappeared when I clicked optimize was evaluate. If I know a little bit about Disney and how I like to tour and I just want to know what to expect, I can click evaluate. That was really fast, guys. What a magical day. Okay, I can see I might be arriving a little late for something. We'll look at that. So evaluate just tells me what to expect based on the order I put the attractions in. And then if you're real silly, you can just print this and bring it to the park with you. It's not a great idea, and we'll talk about why. So in order to wait the least amount of time on this given day, on Saturday, if we were heading to the Magic Kingdom, we would start at Winnie the Pooh, then go to Mine Train, then go to Dumbo, then spin on teacups. Then it has us going over to Tomorrowland before lunch, etc. So without us knowing anything about how crowds behave at Disney World, suddenly I at least have a step-by-step plan where I could print out this piece of paper and bring it to the parks with me and just go from step to step to step to step and trust that I have a pretty great day. You're probably already thinking of problems with that plan, and we'll talk about how we avoid those. But that's pretty cool, right? You would all be clapping if we were in a room together, I'm sure. Yay, we don't need to use any of those. Okay, printing out a piece of paper and bringing it to the park is problematic. You could lose it. Someone could steal it because of the great information that it has on it. But also it doesn't take real-time data into effect. We already talked about Disney has posted wait times every 5 minutes, and we use those to update our predictions every 5 minutes of every day. And so you bringing in your piece of paper that you printed out at home last night or 2 weeks ago is missing a ton of updates and new data to make your predictions more accurate. So you could take your piece of paper and get to Space Mountain and it could be closed because of operational issues or something went wrong, someone puked, and then like you're stuck. I guess you just go on to the next one. Instead, we created an app because people have their phones with them all the time, and they're on all the time at Disney. And that's why Disney does a big business in external battery packs, because people don't realize this and they don't have many places to plug in your phones. So instead, we can put it on an app so you can have all of this information real time, and I can hit that optimize button after every step in my plan, and I can re-optimize using the most up-to-date data. In addition to that, I can get other data available to me. So things like the Swiss Family Treehouse is a really bad example because it never has a wait. But let's say it does. We can see that the posted wait is 5 minutes, but the expected wait is 2 minutes. And we do this for every attraction because those posted waits are never accurate. They're always inflated. They're typically your actual wait on average, if we look at every attraction for the course of a year, is about 63% of what is posted. So you're waiting less than 2/3 of what is posted the vast majority of the time. We also have these beautiful green timer buttons so that we can get more of those actual wait times, more data for us, more accurate predictions for the people that use the app. This is lovely. We can also see our predicted wait time curve over on the right side of the screen for the rest of the day so people can make their own decisions too. So this is super cool. All right, that was all wait times. Now we're more than halfway through. So we're going to speed through, sort of save money and enjoy your vacation a little bit. But that was the big machine learning piece. For saving money and enjoying your vacation, you don't need that much. We'll look at some easy Excel stuff, but I think it's interesting to still go through these parts. Disney vacations are expensive. This is just 4-day tickets for the 4 members of my family. If we went during Thanksgiving last year, I cheated a little bit, almost $3,000, and that we would still have to buy meals. We would still have to buy a place to stay. We'd probably have to pay for our flights down to Orlando. This just gets us in the parks where we can spend even more money. So expensive. How do I save that money? Oh, by the way, this gets us in the park where I can traumatize my 1-year-old by bringing her on Haunted Mansion. Not the best parenting decision I have ever made. Okay, we're going to talk about saving money by avoiding upcharges. You can easily look at things like variable ticket costs and resort costs and minimize by picking when you stay, but we're going to talk about avoiding upcharges in the park. These vary widely in how much they actually cost. So Genie being the least expensive, Genie also has variable cost. So it can be anywhere from $15 a day, which is actually very rare, to $35 a day per person. And it lets you use things called lightning lanes, which are queues that you have to pay to get into if you don't want to be with the masses in the standby queue, and range all the way up to the VIP tours, which you can see there, which cost up to $800 per hour with an 8-hour minimum, but let you skip all the rides and get free snacks and reserved viewing for parades and fireworks. Fancy pants. But let's talk about Genie, because this one's easy to pull data for. So how do we avoid this, or at least make the best use of it? Genie costs the same no matter which park you use it at, and the price changes, but not necessarily with crowd level. Disney tries to make it so that it costs the least on the least crowded days, but Disney is not perfect at predicting, neither are we. But I think we're better than Disney, and so it doesn't always track. But I can use this to sort of time when I might purchase Genie based on the amount of time that it could save me. And so in our brains, we would think, oh, I'm just going to buy it on the most crowded day at the park with the highest wait times, because then I'll save the most time. So the park with the highest wait times in Walt Disney World is Hollywood Studios. Almost every attraction there is a headliner with over hour-long waits. But on high crowd days, in most situations, buying Genie Plus will only save you about 100 minutes in the course of the day. I say only. 100 minutes is still a lot of time. But this is because everyone behaves this way and buys Genie on a high crowd day at Hollywood Studios, and they only have a certain number of reservations at every attraction to use the lightning lane, and those book up quickly, and then suddenly they're gone, and you can't use more than 2 or 3 of them, about 2 of them. You save 50 minutes at each, and then you're done for the day. So actually, the best use of Genie is at Magic Kingdom, where there are so many attractions to use the Lightning Lane for. And on medium crowd days, not enough people are buying it to make the reservations book up too quickly, and you can save 210 minutes or more. So this is really cool. These numbers are a little outdated at this point, actually, because those wait time savings at almost every park have gone up quite a bit. You can also buy individual Lightning Lane access. So these are the most popular attractions at each park, and they're not included on Genie because that would make too much sense. Instead, they make you pay even more money to skip the lines at these attractions. And their cost varies as well. They're not all the same set cost. Rise of the Resistance is actually the most expensive. Tron is now also an individual Lightning Lane attraction. I just haven't added it in here yet. It's only been open almost 2 months now, so not a ton of data, a lot of data, but not a ton of data. Eventually I'll add it onto here, but I can see how much I have to pay to save a minute of waiting at each of these attractions on weekdays and weekends, because that's how their price varies typically. So the best use of my money is buying a weekday individual Lightning Lane for Flight of Passage, because I'm only paying 20 cents per minute to skip that line. These are back to the Genie Plus attractions, and I can see the average time saved at each individual attraction if I use Genie Plus. So if I buy Genie Plus and use it just on Mad Tea Party and Dumbo and the Speedway, that's a terrible use of Genie Plus because they don't have long lines anyway. If I buy it, I want to make the most use of it. So at Magic Kingdom, I'm going to book Peter Pan's flight first, then Jungle Cruise, then Splash Mountain, which is now closed. And at Hollywood Studios, I'll book Slinky Dog first, and then Millennium Falcon, etc. So I can start to make better use of my money and my upcharges. I can also do things like heat maps. So this represents Animal Kingdom and the Genie Plus attractions there, and when I can expect my return time to be based on when I make my reservation. So along that x-axis essentially is when I make that reservation. And then if I go down to a specific attraction, I can see when I could return. So on a medium crowd day, if I'm making a reservation at 11 a.m. for Navi River Journey, which is just a slow boat ride, kind of like It's a Small World, my return time will probably be 4:45 p.m. If I was planning on leaving the park at 2 p.m., that would be a problem. The colors represent when these book up for the day, so no other reservations are available. So if I don't even book Kilimanjaro Safaris till 1 p.m., I probably won't be able to book it at all because it will have already sold out for the day. None of which Disney tells you. So this is important to have. And then finally, we want to enjoy our vacation. Here's two of my family members enjoying their vacations. How do we do that? So we talked about post-visit user surveys. Here's your cheesy Excel graphs that don't require any machine learning at all, but actually make things really easy for humans and help them make decisions that they otherwise wouldn't have made. So we do restaurant satisfaction just on thumbs up, thumbs down. I'm pushing to change that because I think a Likert scale would be a little more helpful, granular. But I can do that percentage thumbs up on my y-axis and the average entree cost on the x-axis. And then if I mark sort of the medians of both of those things, I can get what I call my magical quadrants. So up here in the top right are restaurants that are really high satisfaction, but also really high cost. So I'm going to be paying a lot of money, but I'll know that it's worth it. You'll notice a lot of these are orange. That's resort dining. And in the real version, that's not a PowerPoint deck, I could hover over this and see exactly which restaurants these are. I'm aiming for these restaurants, which are below average cost, but above average satisfaction. And we can see they're sort of all over the place. There's resorts in there. There's a lot in Epcot. That's the blue dots. A few in Magic Kingdom, a few in Hollywood Studios, some resorts, some Disney Springs. But Epcot's really the park you want for inexpensive, high quality dining. Most of all, I'm avoiding the bottom right quadrant because those are higher than average cost and below average satisfaction. Definitely don't want to go to that one. I think that's STK in Disney Springs. But I would otherwise, how would I know this? I wouldn't. I would be Googling reviews from somewhere, trusting influencers to tell me where to eat. And I don't want to do that. I want to make my decisions based on the data. Darn it. Okay. We can also look at which reservations might be easy to get versus that satisfaction instead. So regardless of cost, where am I likely going to be able to eat? And we do this because we have a reservation finder tool. So we can see when that reservation finder is unsuccessful, that means it's hard to get a reservation there. So things on the right side of the graph, easy to get a reservation. Things on the left side, hard to get a reservation. So hard to get a reservation and not very satisfactory. Boo. If I want to have just an easy go of it, easy to find reservations, higher than average satisfaction, I'm going to hover over these and decide where I can eat. Again, a lot of resort dining. This is the trick to dining at Walt Disney World. Travel to different resorts and eat there. The end. There's your trick. And then we have hotels. So a hotel cost is going to be the most expensive part of your vacation, especially if you decide to stay on Walt Disney World property. But like our dining, there's fewer resorts than there are dining options. So this is a little easier to make our decisions. We can do our average satisfaction. So this we do a Likert scale for. So 5 is perfect, very satisfied all the time. 4 is satisfied. 3 is meh. 2 is dissatisfied, and 1 is very dissatisfied. You can see every single Disney resort has an average of 4.4 or more. So we're sort of nitpicking here, but for this cost, you want to nitpick. The x-axis here is average nightly cost of a room. And so I averaged it across all rooms that are available and all days of the year. And this is the average nightly cost. So you range from the all-star resorts, which are down here at $200 a night, to the villas at Grand Floridian, which will cost you a cool $1,500 a night. And then you can graph them against that satisfaction. So the blue line here is our average, and then we have our sort of 95% confidence interval that I'm calling our upper and lower bounds. So anything above that confidence interval, I'm saying is above average satisfaction given its cost. And anything below the orange line is below average satisfaction given its cost. So you really want to stay at Port Orleans French Quarter. This is what I'm telling all of you and myself. I've never stayed there, even though I know the data. Much, much higher satisfaction than you would expect given the cost. On the other end of the spectrum is Caribbean Beach, Saratoga Springs, and my favorite, Animal Kingdom Lodge, Kidani Village. People are crazy, I guess. I love Animal Kingdom Lodge, which, by the way, is where we took this picture. Also a not good family picture. She scraped up her knee pretty bad as I was taking that picture. I guess that's why those cones were there. But no, there weren't cones at the top of the slide. Who knew? I just said, go down the slide. I'll take your picture. Terrible. Terrible mom moment. Even if I pick, let's say this is another part of Animal Kingdom Lodge. This is Jumbo House. That picture was at Kidani Village. My experience at this resort could vary pretty wildly based on which room I choose. These rooms are about a quarter mile from the lobby versus these, which are right next to the lobby, which comes with good and bad. So we have this room finder tool that can give you all the data you need to make a decision. At Animal Kingdom Lodge, the biggest difference in price comes from whether you stay on this side of the resort, which are quote unquote standard views, or this side of the resort, which are Savannah views. And the difference there is about $200 a night on average. But we have pictures from every room and every resort on property. And you can see this one, which is right next to the lobby, which is a room I have personally stayed at. This is room 4210. And this is a picture from the room. And there's animals there on a savanna. And it's a standard view room, which you can see somewhere. Oh, standard view with 2 queens. And you can see public comments from years and years ago and up to yesterday that talk about how animals actually get fed here. And you don't have to walk very far to the lobby. This is a lovely room. I request this room every time. And actually, you can request this room. And because Disney is still living in the dark ages, this will actually put a queue for us to send a fax to Disney. Can you believe it? We're still sending faxes. Machine learning and faxes in the same presentation. You're welcome. We're sending faxes to Disney to request these rooms and have a pretty high success rate. can also do this for attractions. We're running low on time and I want to leave room for questions. So I can do things like predicted weight versus satisfaction. So I'm going to go again to this upper left quadrant where we have high satisfaction, below average weight. And if I know nothing else about what I like about Disney, I would aim for those. And we have this for every age group as well. So we can look at that pretty granular. Always encourage you, like the end of this process, once you apply the data and you learn things, is thinking of more things to do. So what would you try to do with all of this data? One idea that I'm currently working on is sort of a Pandora for Disney World. I don't know if you all have Pandora. So app where you listen to music and give it thumbs up and thumbs down, and it learns about you and gives you music to your taste. You could do the same thing at Disney. I could give you very basic information about me or my traveling party, and you would send me to my first attraction of the day. I would give it a thumbs up or a thumbs down based on what it learns about me and current wait times. It would send me to another attraction real time. Planners like myself would hate that. People who hate the planning would love that. So lots of things you could do with this data. Highly encourage you all to work with that and try to imagine it yourselves. I have my contact information here, very active on Instagram. Like I said, I blog multiple times a week, so you can find that there. Or you can email me. The @ is missing. It goes after my name and before centric. I'm sure you can figure it out. You're smart people. This is my thank you slide, not this picture. We're all supposed to be walking like Timon and Pumbaa and Simba. That didn't work. We discovered that we randomly had stuffed monkeys with us on one of our Magic Kingdom days. There's my other daughter on Buzz Lightyear. It's a great ride for family photos. There we go. All right. We're going to end with this one. We can get good family photos at Disney. And I'm going to pause now for any questions that you all have.
Hello again, Becky. Thank you so much for the awesome talk, and thanks for all the examples of good parenthood. I will remember those.
It's your bonus. It's your bonus for this.
Yes, like the soft skills we talked earlier about.
Yeah, there you go.
All right, Becky, we actually only have one technical question. I would say let's start with this. Sorry, maybe I missed it. Where have you all the data for queue times from?
The queue times. So number one, Disney World has an app where they post all of their wait times for people that are in the parks, but anyone can access this app if you just Google Walt Disney World. And it's very, very easy. I won't get into the technicalities of how, because that might get me in trouble. Really easy to scrape that and store it in a database. And so that's what we do. Every 5 minutes, we scrape their wait times. But then also we have our own app where people can record their actual wait times, and that goes straight into a database in AWS as well.
All right. Hacker girl, I see.
Yeah.
All right. Then the next ones are more, Disney focused.
Perfect.
As was your talk. So
bring them
it's
on.
only fitting. Okay, first one is actually not a question, but a statement. I've never been to Disneyland before, but after this talk, I feel like I've been there at least 10 times.
Good. Me too. I've been to Disneyland once, actually. So mostly Disney World.
Of course, you're going to Disney World, not Disneyland. What's the difference? Is one better or worse, or is it just like same?
Disneyland in California has 2 parks, Disneyland and Disney's California Adventure. Disneyland was the original Disney park, built in 1955. So I won't say better, but original. Walt Disney himself created, built it, lived in it. He had an apartment on top of the fire station on Main Street. Walt Disney World is sort of the Disney Mecca. It has 4 theme parks in one, those 34 resorts. You could stay there for 2 weeks and never need to go anywhere else, although that would be pretty sad. So it's just a lot bigger. Disneyland, you can hop back and forth between the 2 parks and accomplish a lot in the day. You have to take buses or other transportation between the Disney World parks. So Disneyland is quaint, original. Disney World is like on steroids. Those are the differences.
All right. Yeah. Hey, some Disney lore also right there. Awesome. Always happy. when the scholars share their
There you go.
knowledge.
Yeah.
Yeah. Thanks for that. Next question is related to Disneyland, but let's just make it Disney World or both of them. Now, please tell us, what's your favorite ride in Disneyland/World?
/Disney World. Disneyland. Okay, so here's another good Disney trivia fact. And if I had pictures, I would pull them up really quick. On both coasts, there's a ride that was originally the Tower of Terror. And so it's an elevator drop ride. It's themed to the Twilight Zone, and it was themed to that originally on both coasts. In California now at Disneyland, they rethemed it to Guardians of the Galaxy Cosmic Rewind. It has a really cool soundtrack because those movies have cool soundtracks. That's probably my personal favorite. They also recently opened Web Slingers, where it tracks your arm motions. And so you're being Spider-Man shooting things and you get a score. And my elbows get so tired on that ride from doing that. So those are my two favorites from Disneyland. Disney World is a lot harder. Living with the land is not something anyone else will tell you. It's in Epcot. It's just a boat ride through greenhouses. But the technology in those greenhouses, it's real live research. There are researchers there every day learning about things like hydroponics, etc. That was the original intent of the Epcot theme park, was it as a place of learning. And I love that that piece of it is still there. So that's my personal favorite attraction in Disney World.
Oh, that's awesome. For science.
Yes, for science.
Next one is also kind of a statement. I was in Waterworld in Barcelona. I'm sure you would like it. Maybe you know it?
I don't know it. I've been to Europe several times, but I've never done a theme park in Europe. There's too many other things as an American for me to go see and do. But if anyone wants to host me, reach out. And I will gladly do a tour of the theme parks in Europe.
Yeah, I can imagine like a theme park. You have enough in America. It's not
right.
The thing you're looking for in like the old world.
Right. Yeah, exactly.
Right. Since you're a vacationer, you also stated it yourself at the beginning of your talk. What's the next vacation plan for this year or the next several vacations?
Yes, several locations. So I'm going to Wisconsin in July. That's for a conference. So there's a series of family conferences here in the States. I don't know of any in Europe. Otherwise I would plug them. But they have technical tracks like this one. Usually attendance is between 700 and 1,000 people. So they're pretty huge. They happen at an indoor water park resort though. There's one in Pennsylvania, one in Wisconsin, one in Texas. And so in addition to all of these adult tracks, typically 8 or 9 talks going on at a time, they have a family track where your kids can go. And so last year my kids made slime. They did marshmallow engineering with marshmallows and toothpicks. They made robots out of pool noodles and electric toothbrushes. So it just sort of rattles and draws. So that's July. We're going up to the Wisconsin Dells and helping my kids learn to be engineers. In August, we're flying out to California, but we have a goal to bring both my kids to all of the national parks here in the US before they graduate high school. So we are hitting Crater Lake National Park, Lassen Volcanic National Park, and Redwood Forest National Park. And then in September, like I mentioned, the week of Labor Day is the week to go. We will be in Disney World, enjoying our time there.
It's like coming home for you, going to Disney
It
World.
Is. It just feels, yeah, you just know.
Yeah. And since it's like coming home for you and you're certainly the pro here, maybe let's close the session by maybe you have some advice for the perfect day in Disney World, maybe for people who are first timers and want to get the experience, the Disney World experience.
Yes. Well, if you want the classic Disney experience in one day, you just have to go to Magic Kingdom. That's what you do. It is the most Disney park. My perfect Disney day actually starts in Animal Kingdom. It opens the earliest. It's the most relaxed park. There are a couple rides with really long lines, Flight of Passage being one of them. But you've got everything from roller coasters. Expedition Everest is a roller coaster that goes forward and backward. Flight of Passage. If you haven't seen the Avatar movies, you ride a Banshee and you're kind of on this bike and it breathes like it's really cool. But then you have just relaxed. There's a safari ride where you can see the giraffes and zebras, etc. So I would start my day there and then go back to my resort for some pool and nap time, and then end my night in Epcot in the World Showcase, where they have a bunch of countries represented, really excellent eating, a fireworks show over the lagoon at night, and staying there in the evening. So that would be my recommendation for avoiding all the crowds and having a good day.
Thanks for that. Yeah, you're certainly a pro. I see it when you have like scheduled also your nap time, when you know when it's time to slow
You need
down and
rest.
to move
These
on.
are long days. You don't want to be cranky at
Yeah.
Disney. So
Yeah. Don't destroy the spirit. Right. Becky, thank you so much for the awesome talk, also for the Q&A, and for all the good vibes you brought us today at the end of our live day. And hey, maybe we see us on the next live day. And until then, have fun with your kids.
thank you so
in the
much. Thanks for
summer, and
having me.
Yeah.
Thank you.
See you soon. Bye. All right. And now, after the last talk, that also this live day slowly but surely comes to an end. Just a quick reminder, if you're based in or near Vienna, yesterday started the Vienna app. Make sure to check it out via the link in the chat. And while you're at it, also go to worldcongress.dev for further information on our upcoming in-person event end of July in Berlin. Check out the speakers, check out the tickets, make sure to get the last ones. And also, thanks to our partners. To see them, scroll down on the live page. We prepared them as clickable logos. Click through them, look at what they're offering, and leave them some love on the websites. It wasn't events like this wouldn't be possible without them. And of course, also thanks so much to the audience. Thank you so much for engaging and to switching in today. And hope to see lots of you on the next live day, which is actually the last one for this season. But don't worry, next one starts in September. We'll keep you covered. And the next one is on June the 7th, when it's all about the cloud. See you there. Bye.
You made it. Welcome to Vienna. We are so glad you're here. This event is part of Vienna Up, the Startup Festival. Have you got your Vienna Up wristband? Put it on and enjoy special offers and activities. Swing by the festival home base, say hi, hang out, and enjoy Viennese Hour to sample local food, wine, beer, and soft drinks for free. And have some fun while making new connections. Visit partnering traditional Viennese coffee houses to sip a free melange, meet new contacts, check your email, or just have ideas both crazy and grand. Enjoy Vienna. Go to viennaup.com, sign up for the newsletter for daily highlights, and we'll see you at the home base.